In this video, we'll talk about how we can use Spring Boot in Java to create a REST API and also learn about different concepts and tools which Spring Boot provides to build a better application and build better web services. So in this video, we'll talk about how we can create a Spring Boot project and also run a Spring Boot project and see the server running. So the best part about Spring Boot is that you don't need a Tomcat server running separately and have a Java project connecting with it. Everything is provided by Spring Boot. All you have to do is know the basics of Java and some basics of Spring. So to continue or to watch this video, make sure that you have some basics of Java in your pocket and also some basics of Spring. You can find them in the programming knowledge channel, and once you're done with that, you can come ahead and start watching this video. So in this video, we'll talk about how we can create a Spring Boot project. So for that, the first thing which you need is an IDE. So the IDE which we're going to use for this video is Spring Tool Suite. So it's by or for Eclipse, and it's completely open source. So go ahead and download the one which you have for your operating system. I have a Mac, so I had downloaded the Mac 64-bit Spring Tool Suite. And yeah, so once we are done with this, you can start following the tutorial. And so this is how your Spring Boot tools look like. So we'll be creating a REST service or a REST API. And this is going to be the hello world of REST API, which is going to be a to-do list API, where you can add tasks to your to-do list. You can delete them, you can update them. So you'll have all the CRUD operations, which is create, update, and delete. And we'll be building that using Java, Spring Boot, and we'll see how we can connect to the database, a MySQL database, and also see how we can work with REST services. So what is a model view controller, the MVC architecture, and how does that work? So we have a lot of cool things going to happen inside our tutorials. So keep watching, and let's start first creating a Spring Boot project, which you can use to actually start building up on top of your Spring Boot application. So I have my Spring Boot Spring Tool Suite running, STS for short. And what we're going to do is we're going to start a new project. So it can be anything. It can be a Java project, a Spring Starter project. But the most easiest way or the most comfortable way I know to start one is to create a Maven project. So go to Other, click on Maven project, or Next. And we'll be creating a simple project, and we can build on top of that later. So we have a very simple project here. Go to Next, give it a group ID. So group ID is basically a name for what you want to do. So we'll just call it to-do list. To-do list. The artifact ID is going to be the same. And we'll let the version be 0.0.1 snapshot, nothing against that. And the name is going to be again to-do list. No need to give a description here, and we'll add a parent later. So simple naming conventions to our project, a to-do list API. So we'll have it the name as to-do list. When we click on finish, and we have a to-do list project here. So as you can see, we haven't added anything to our project right now, but there's still a lot of things here. So we have a JRE system library, we have Java resources, test folder, a POM.xml. So we'll talk about what Maven is and what POM is. And before all of that, the one thing which I forgot to mention was that you need to have, which is unobvious, you need to have Java installed in your computer. So make sure that you have Java. So you can just do Java-version and make sure that it's 1.8 or above. I don't know if there's another if there's a newer one than 1.8, but make sure that you have Java installed and you have it, and you can confirm it by running Java-version. Great. So now that we have created our to-do list project, a Maven project. So Maven is basically a single point of repositories where you have all your jar files. So if you want to add any jar files to your project, add an API or add a framework or a jar, you can do that by using Maven, and especially this POM file. So the POM file basically acts as a way for you to download jars in your project by giving the POM file the name, the version number of the jar which you want, etc., etc. So this is how you actually do it. And we'll be filling up our POM file first. Make sure that we have all the things which we need to start our project. So let's start by doing that. So let me just quickly open the POM here. So first thing which we need is a parent tag. So I'll talk about this in a minute. So this is a parent XML tag, and the parent is basically Spring Boot starter parent. So this tag tells the project that the project is a child of the Spring Boot parent jar. So this tells the project that we'll be using Spring Boot, and this is a Spring Boot application which we're going to build. So again, group ID, artifact ID, the names, the version, etc., etc. And this is how we tell our project that this is a parent project or a child project of the parent, which is Spring Boot. Okay, the next thing which we need is simple dependencies. So dependencies are basically the jars which is going to help you get automatically installed in your project, and you can just use them directly. The first thing which we need is Spring Boot Starter Web. This is basically provides you with all sorts of annotations and functions which can help you quickly build a REST API or web services very, very, very easily. And after this, another thing which we need is the properties tag. Allocate some properties to our file. So we have properties Java version 1.8, as you guys know. Just hit refresh and make sure that everything is stable. And before we complete, the last thing which you need to do is basically update your project. So go to your project, right click on it, and go to Maven and click update project. Okay, just to make sure that your dependencies are downloaded and your POM files are ready, and to make sure that your properties is 1.8. Okay, so great. We have updated our Maven file, Maven project, a POM file. So POM file has three things. First is the parent, which is a Spring Boot starter parent. Next is dependencies, which is Spring Boot starter web, which gives you all sorts of annotations, functions. And the last thing is properties, which is the Java version, which you're going to use inside our project. Okay, the next thing which we need to do is create a starting point for our Spring Boot application, which basically runs the server. So once that is done, we'll actually have our server running on top on port 8080 localhost and see how that works. So let's start by doing that. Let's start doing that now. So in your src main Java, right here, you're going to create a new class, which is going to be to-do list. Let me just say to-do list. Yeah. So this particular class is going to be having a main function, main method, because this is the starting point of how we actually run our Spring Boot application. So click on finish, and we should be good to go. Give it a minute. And great. So now we have a to-do list starting point for our project, and all we need to do is just have a couple of annotations to actually run this. So to actually make this Java project a Spring Boot project, so make sure know that this is still a Java project. We have downloaded and installed the jars and dependencies which we need on the POM file, but we haven't actually used them. So it is still a Java project or a Maven project. So now what we do is make this a Spring Boot application. So for that we have some annotations. So first we do is Spring Boot application, and we import that. So if you just hover on top of it and you just do this, now this has officially become a Spring Boot application. And the next thing which you have to do is basically run it. So you say Spring Boot application dot run. So let me just quickly see what this was. I keep forgetting the syntax, so sorry about that. It's a Spring application, my bad. So we have booted it, so we just do Spring application dot run, and we have two arguments here for our run method. First is the source, basically which is going to ask us or tell the project where to run or what class to run. So we'll be running the to-do list.java file, the class. So we just say to-do list.class. and the arguments are going to be args which can be passed running the project right from here. So this is how we actually create or develop a Spring Boot project. Now let's run this and see what we get. So we'll be running it as a simple Java application because the annotations handle the Spring Boot part of it. So we don't have to worry about that. Press OK. And we just wait for a couple of minutes. So they should be showing on the bottom, but I have it on top because I think it's easier to see what's running and what's not. So you don't have to worry about that. So now when you scroll here, you see that the Tomcat has started on port 8080. So we can go here, go to 8080, click enter, and so we get a white label error page. So basically, we just ran a server, so we don't have anything yet on the server. And when there's nothing, Spring Boot goes to the error/error page. And as there is no explicit mapping for the error page, you see this as fallback. This is a default by Spring Boot. So don't worry, you haven't done anything wrong yet. It's perfectly working. The Spring Boot server is on, and you have a web service already there. The server is up without anything, any much effort. All you have to do is now keep adding stuff to it so that this becomes a fully fledged REST application. So that's it for this video. In this video, we talked about how you can actually create a Spring Boot project efficiently, and in the next video, we'll talk about how we can create or implement a REST controller using Spring Boot and keep continuing this tutorial. So just to reiterate on what we had done since the beginning, first we install Spring Toolsuite for Eclipse, open source, anything works here. Next, you create a new project. So go to File, New, go to Other, and create a Maven project. After you're done with that, go to your pom.xml, and let me just close this. Yeah, go to your pom.xml and add the Spring Boot starter parent as your parent ID, and add the dependencies of Spring Boot starter web, and make sure that your Java properties are 1.8 so that this is ready to actually start building up your Spring Boot application. In this video, we'll talk about how we can create a Spring Boot application and also implement a REST controller. So in this video, we have a to-do list API, which basically can perform CRUD operations, create, update, delete, using Spring Boot, which we'll be using to develop our REST API. And in this video, we'll talk about how we can implement a simple REST controller. So a controller is basically a Java class where you can handle URLs and API endpoints, which then passes on the logic to the service or to the model. It's the database. So controller is your starting point to your URL and how we can actually work with a URL or an API endpoint. So let's get started. We'll be making a very simple get request using a controller. And a get request is basically when a client asks something or gets some data from the server. So if I want to get a task or get all of my tasks from a to-do list, I do a get request, and then that fetches me a JSON or any other thing which then acts as the data which we get from the REST API or the server. So let's get started. First, we need to create a class. So go inside Java, src main Java, and here go to new class, and this is going to be inside something called as hello. So we'll be making a get request called as hello, and we get back let's say namaste from the server. So let's see how we can implement that. We'll call this hello controller. So a very common naming convention in Spring Boot, being very opinionated, is that you need to, it's good practice to have the controller name inside your class whenever you're implementing a controller. So, which tells the user that this is a hello controller. Great. So we don't need a main method here. We just need hello controller, and all we can do is press finish. And here we have it. We have our controller now. Again, this is not a Spring Boot REST controller yet. It is simple. It is just a Java file or Java class. So we have to annotate this to let Spring Boot know that this is a REST controller. So for that, we do an @REST controller, and we hover on top of it, and we import it now. So now basically, now our controller is a REST controller because we annotated the class with it. So this is how, when Spring Boot on starting up, it does a class path scan. It basically scans all your classes and sees all the annotation on top of it and then acts accordingly. So this is how you tell Spring Boot that, okay, this is a controller and everything inside will be having API endpoints. Great. So now let's start developing our first controller or implementing our first controller method. So we'll be doing a request, a get request. So for that, we need to have a way to map that request to a function or a method inside our controller. So again, Spring Boot provides you with something called as request mapping. So you use request mapping to actually map your endpoint to the method. So let's do request mapping, and we go to /hello. So we will have to implement or get this. So let's give it some time. And we have a public string say hello. Great. And let's import request mapping. Awesome. And we return namaste. A very simple controller which greets you when you ask or request something or ask for a hello, right? Nothing complicated, nothing complex, just a simple controller. So here, what happens behind the scenes is that whenever you access localhost port 8080 or base URL /hello, that /hello is mapped with this function, the say hello function, and it returns back namaste. So in this video, we'll talk only about how we can return a string, but in the upcoming videos, we'll actually return objects and much more complicated data structures than just a string. So here, we use the request mapping annotation to have a /hello mapped to the function. And as you can see, Spring Boot makes it really easy. And if I have to actually go all the way and say, it makes it as easy as Python to actually develop REST controllers. So it's as simple as this. You have a REST controller annotation and a request mapping annotation. You have a function, you have a return value, and you're done. So you have a get request working completely fully without any other thing to do. And all we have left to do now is to run this, and we can see that when you do a /hello, it returns back namaste. So let's try that. We do go here and we run it. So give it time. It's really nice ASCII art here, so I really like it. Okay, so application failed to start. Why is that? Verify entity stop process. Okay. I already might have something running, so yeah. So let's stop everything. My bad. And okay, now that we have stopped everything, we start it again. We really shouldn't have got lost on that. Okay, so now I can see that Tomcat has been started on port 8080. So we had our previous server running. So now when you go to localhost port 8080, not 808, 8080. Yeah. So again, we get this page, but when you go to a /hello, we get a namaste back. So this is how you implement a REST controller using Spring Boot. And this is a very simple tutorial, a very straightforward tutorial. In this video, we'll talk about Spring MVC framework, which is the model view controller framework. And we'll also talk about how entities can be made in a Java or a Spring Boot application. So in the previous video, we talked about how we can create a simple REST controller, and we also talked about how we can actually create a Spring Boot project. And in this video, we'll actually dive deep into the concepts behind a REST API and behind how Spring Boot actually is used to implement a REST API and all the magic that happens behind the scenes when you open a website. So what is a business service, and what is a controllers, and why do we make controllers, and what's the abstraction. So we'll talk about all of that in this video and the upcoming videos. So the main topic for this video is going to be Spring MVC framework, which is a model view controller framework. And after that, we'll actually start implementing our REST API, which is a to-do list API. So we'll talk about how we can implement a to-do entity, and we'll see how that interacts with the rest of our application in the future videos. So let's begin. So first, we talk about the Spring MVC framework. So the Spring Web MVC framework provides something called as a model view controller architecture, and it's already ready with components that can be used to develop flexible and loosely coupled web applications. So it's not tightly coupled. So you have a lot of things which you can optimize and customize according to your needs, and you don't have to always follow something which is opinionated. So what are the three things inside the MVC framework? So the first is the model. So as you can see here, the model encapsulates the application data, and in general, they will consist of POJO. So POJO is a plain old Java object. So usually model is basically a database. So you're a Java object. So if you have a plain old Java object, that is then converted into a row in your database or a database schema, and then we use that to actually talk to our application, talk to the controller, or talk to the view using a model. So the model basically encapsulates the data which the application uses. So here in our to-do list example, which we're going to actually implement, the model is going to be the name of the task in the to-do list, the summary of the to-do list, and the description of each task in the to-do list. So yeah, that is what model is. The next is view. So the view is responsible for rendering the model data, and in general it generates HTML output that the client's browser can interpret. So again, let's map the understanding of view with what we're going to implement. So view generally is considered of the HTML output. So basically this framework which you see here, this website which you see here, whatever the buttons and everything is the view of the application by tutorial's point. But since we will be creating a REST API, our view is going to be simple JSON, JavaScript object notation. So that is going to be our view, which can be interpreted by some browsers and some not. But we'll be using Postman, which is used for handling APIs. So we don't have to worry about the view as of now. The next and the most important part, I feel, is the controller. So the controller is responsible for processing requests and building an appropriate model and passing it to the view for rendering. So the controller takes in the data from the model, and then has the business logic inside it, or the business service, and then it passes it to the view for rendering. So what happens behind the scenes? So the Spring Web MVC framework is designed around a dispatcher servlet class that handles all the HTTP requests and responses for you. So you don't have to worry about all of that. You can just focus about your problem which you want to solve. So the workflow is as follows. So after receiving an HTTP request, so let's say you have a GET request where you want to get some data from the server. Let's say you want to get all the tasks in the to-do list. So the dispatcher servlet consults the handler mapping to call the appropriate controller. So the controller here is going to be get to-do list or get all to-dos. Now the controller takes the request and calls the appropriate service methods based on the used get or post method. So we will be having a service method which actually talks to our database or talks to our model to actually get that data and then give it back to the view. So the service data will set model data based on defined business logic and returns view name to the dispatcher servlet. Now, the dispatcher servlet will take help from view resolver to pick up the defined view. So we don't have to worry about this step for our implementation because we'll be having a JSON output. Now, once the view is finalized, the dispatcher servlet passes the model data to the view, which is finally rendered on the browser. So all the above components, the handler mapping controller, are parts of the web application context, which is an extension of the plain application context. So we'll talk about all of these annotations and all of this context in the future videos, but just remember this diagram and how the MVC works. So M is model, your data mainly. View is how we actually see the application. So we'll be having simple JSON objects in our view for now. And controller is where you actually handle requests and figure out the business logic for your application. Great. So we'll be building our web application around the MVC framework. So we need to know how this works before we actually dive into the implementation. Now let's start actually building our to-do list REST API using Spring Boot. So let's close the hello package. So we don't want to use this. So it's just an example. And let's actually create a new package. So go to src main java in your to-do list. Go to new, go to package. And this is going to be to-do list dot to-do. So this is what will be named our package. You can name it anything, but I think this is the most easiest one to name. And next we need a simple class. So now the first thing which we have to do is create an entity, a to-do entity. So an entity is basically a real world object in database. So in databases, it's a very common thing to talk about entities, and we'll be mimicking that in a Java class. So this class will contain all the information about a to-do object, right? A to-do entity. So what will the to-do include? So a to-do or a task will include an ID, a unique ID, which can be used to access any of the to-dos or the tasks. It will have a name. So the name of a to-do, for example, create a YouTube video or finish the project assignment. So the name of your to-do. The next is going to be the summary or a very short gist of what the task is about. And if you actually have a really important task to do, then you will also have a description which you can actually elaborate how you are actually going to finish the task or what the task consists about. So let's start making our to-do entity. So we'll just call it to-do. So to-do and press finish. Great. So we have our to-do class here now, and let's add some things which we talked about here. So the first thing which we need is a unique ID. So integer ID. Next is string name. So this is all we need inside our entity, but we also need to have setters and getters in simple Java concept for this class, and also have a constructor. So let's do that now. So what we do is go to source and click on generate getters and setters, and let's select all because we need it for all of them, and click generate. And yeah, we have it here. So pretty neat, pretty simple method of doing it. And now what we need are two constructors. So we need an empty constructor and we need a parameterized constructor. So let's make that now. Go to source and generate constructor using fields. Select all and done. So now we have a parameterized constructor here, and we need to actually make sure that this also has an empty constructor because it makes it easier later. So let's copy this now. And let's remove all of this to make it empty. And great. So now here we have a to-do entity. So it has the ID, name, summary, description. It has constructors, and we have getters and setters. So if you ever want to make a task, this is the class, or the object of this class is what we'll be using to create our to-do list objects. So yeah, that was it for this video. We talked about the MVC framework. We talked about model, which encapsulates application data. We talked about the view and controller. So view is going to be JSON for now.
and the controller is where all the business logic and mapping of the requests happen. And the dispatcher servlet also helps you behind the scenes to actually handle all of this for you. So yeah, after that we talked about the entity which we'll be using to make our API. So this is a very basic entity. So everything that happens inside the application will be using this to actually make our tasks in the to-do list. So it'll have a unique ID, name, summary, and description.
In this video, we'll talk about how we implement a GET API, and we'll actually start implementing our REST API. The first API which we're going to actually target is the GET API. So before we jump on to in the implementation, let's first talk about how we'll be doing it. So for a few videos for the API endpoints, we will not be adding a database yet. We will only be having our database in memory with just objects. And later in the future, once we are done with how the controller works or how the business service works, after that we can then talk about how we can integrate a database, a MySQL database into our application. So until then, we'll be having an in-memory database to work with, which will actually mimic how our actual database takes place. So until that, we'll just focus on the controller and the service or the business logic, which we'll be creating for our to-do list application. So in the previous video, this is where we were. We had our to-do entity and we had constructed the getters and setters and the constructor for it. In this video, we'll actually go ahead and actually start making our to-do list API. So now again, we need a new class for our controller. So go to the package and click class. This is going to be to-do controller. Finish. Great. And now here we need to have two methods. So the controller is basically what talks to your request URL. So if you have a todolist.com slash get all to dos, so that actually, or the slash to dos, that actually gives you all the to do list tasks. So the controller takes care of that, and we'll see how that works. So let's create our method. So we have a public list of to do, and there's going to be get all to dos. Great. So let's import the necessary functions. So here we have the list from util, and we return the list of to-dos whenever you ask this. Now, how do we actually map this to the URL? So as we saw in our second video, right, how to implement a REST controller here. So we have to give it a REST controller annotation and also the request mapping annotation. So let's do that now. So to make this a REST controller, we have to give it a REST controller annotation. And we again import it. And to map the request with this method to slash to dos, we need to do a request mapping. And the mapping will be done to slash to dos. Oh, my bad. And let's import request mapping as well. Okay, great. So now we have a method called get all to dos, and which is mapped to slash to dos, but we need to return a list of to dos now. So how do we do that? So the one way could be to actually implement a logic right inside here. So we can just write the logic here and then return that right now. But things are a bit different here. So this is a controller class, so it only deals with the controller and not the business logic or the service, also called as service or logic. So the controller only takes care about how logic or how the data is actually sent back to the view, right, which is the JSON. So we will actually have a service which actually deals with the business logic of getting all the tasks, etc., etc. So let's implement our service class, which is the to-do service. So go again, let's close this and go to to-do, new class, and we call it to-do service. And let's create it. So this class will contain all the business logic which we have to have to actually give back the controller some data. So here first we need a list of to-dos, right? So we have a private list to do called as to-dos, and this is going to be an array list. So new array list, and let's actually implement our array list, right? So this is going to be arrays dot as list, and let's have a few lists here. So the first thing which we have is a new object, so new to do, and the ID is going to be 1, the name is going to be task 1, summary is going to be summary 1, and description is going to be description 1. Yes, so let's just make a few more so that we got enough to work with. We'll call this 2 and 3, and let's import our list. Great. So now how do we actually let Spring know that this is a service? So how do we let Spring know that? Similarly, how when we talk about this being a REST controller, we need Spring to know that it's a service, so that Spring can do a class path scan and then understand that this is a service, and all services are singleton. So Spring only creates one object of this service, and then it keeps using it so that in space it saves time and space. So to do that, we just have a service annotation, and this lets Spring know that this is a service. Great. Now we have a to-dos list of to-do. So it has 3 tasks: task 1, task 2, and task 3. So let me just fix that right now. Task 2 and task 3. Let's do it for this one as well. So it's going to be 2 and 3. Great. So great. Now let's actually implement our method or the business logic. So how we do that is we do a public list to do get all to-dos, and we return to-dos. So pretty simple, pretty straightforward. And now we have the logic here for get all to-dos, which just returns all the to-do list objects. And now we need a way for this to be injected into our controller. So let's see how this works. So we do a private to do service. We create or instantiate a class variable to do service, and to inject all of this inside our controller, we have an auto-wired annotation. So we'll talk about what auto-wired is and what dependency injections are. So basically, the service is dependent on the controller is dependent on the service, and we want to use the service inside our controller. So we talk about how we use dependent injection in a later video, but let's see how this works now. So now that we have our to-do service, all we have to do is do to-do service dot to-do service dot get all to-dos, and we're good to go. So this is how we actually get all the to-dos, and let's run this and see how this works. So we are inside to-do list. So cancel, go down to-do list. Okay, let's see how this works. Just run. Could not find to-do list dot to-do list. Okay.
let's write here Java application. Great. Yeah. So let's wait for the server to be spinning up, and then we can actually test this to see if it works. So as you can see here, we have our to-do list ready. So let's go to our browser. So let's go here and let's go to port 8080 and let's see slash to-dos. So here, as you can see, we have our task 1, task 2 and task 3. So I named it wrong, but yeah. So we have our 3 tasks here, and this was with the help of the method here. So if I close this and cut it out, so here we had a slash to dos and we had a to do service. So let me quickly fix this. So we have 2 2 2 and 3 3 3, and this is going to be 2, this is going to be 3. Great. So this is how we actually implement a get API, and now let's actually have a get API for getting it by ID or just getting one to-do list. Or so we do again a request mapping, and now we don't want only the to-dos, we just want one to-do, right? So we just want the ID, but the ID here is a variable, right? It's a class variable called as ID. So to actually have variables inside your URL, we use curly braces and we put our variable name inside that. So now whenever you have an ID 1, ID 2, ID 3, it will be mapped as slash to do slash 1 slash to do slash 3. Okay, so we do a public do get to do, and this will have the integer ID. Now we need we need to tell Spring Boot that this ID is the same as this one inside our URL. So for this we have an annotation called as path variable. So path variable basically tells Spring Boot that this one, the ID here, is going to be mapped to the ID in the URL, and all we have to do is do a return to do service dot get to do and pass in the ID. So we haven't implemented get to do yet, so let's do that right now. So we create a method here. Great. And all you have to do is return to dos dot convert it to a stream, and then we filter the stream. So the filter is going to be a lambda expression. So for every to do, every task, we have to get the ID and check it if it's equal to the ID which we pass, and if it is, then we do a find first. So we find the first one and we do a dot get to it. Oh, sorry, we'll find first and dot get. Yeah. So let's see what the error is here. Types mismatch for a stream. Oh, okay. So we need to do dot filter. Okay. Oh, my bad. Yeah. Okay. So stream dot filter equals ID dot find first dot get. Yeah. Great. So here what we're doing is we are filtering all the to-dos, getting each of them by ID, then we compare it with the ID here and get the first one which we find. So how does the workflow look like? So we have the to-do slash ID, we have the integer which is passed into to-do.service, and we get the ID. We go to the service and we filter it by the ID and check if the ID matches anything inside here, and we get it back. So this is how we get one single to do using the ID. So let's run it again and see how this works. Run as Java application. Up in no time. So yep, so we have our server ready. So all we have to do is do /1 and we get the first to do now. So as you can see, we have the first to do. We go to 2, we have the second one, and when we go to 3, we have the third one. And if we go to just /to-dos, we have all of them here, as you can see. So this is how a get API works inside Spring Boot.
In this video, we'll talk about how we can implement a post API in our Spring Boot REST API application. So in the previous video, we talked about how we can implement the get API. So where we get all the to-dos from the server, or we get a particular to-do which is by the ID from the server. So let's just refresh what we had done in the previous video now. So we had built a business service or a to-do service which handles all the business logic for our application. So for initially, we now have an in-memory database where we have objects inside an array, but later in the videos, we'll actually convert to a proper database, and then we'll actually use the JPA APIs and etc. for our database. For now, we have a simple in-memory database, and the logic for our APIs is here. So for getting all the to-dos, we just return all the array list, and it is automatically converted into JSON when we return it back to the view. The next thing which we did was we had implemented the get to do, which gives you a task based on the ID, which is unique, and we use streams filter to get it. So we had converted our array list to a stream, we filtered it by the ID, which is equal to the ID given, and then we got the first one which matched the ID. Now in this video, we'll talk about how we can implement a post API and what we have to do and the kind of business service that we have to write. So let's get started. So now to do a post API, there are some changes which we need to do in the annotation for the request mapping. So let's see what that is now. So we need a request mapping because we need to map the request. So request mapping, and we do, and now instead of just this one, what we have to do first is we need to tell Spring Boot that this request mapping is a post mapping and not a get. So all of these are get by default, but we need to specify explicitly that this one is a post method. So for that, we have an argument called as method, and all we have to do is make it to the request method called as post. So request method dot post. And now the next thing which we need to do is pass in the URL where we have to give out the post request. That is going to be /to-dos only. So let's see how this works now. So now we have our usual post method. So public void create to do, and now we have a request body. So we will have a request body where we actually pass in the JSON to create a to do, and the JSON will contain the ID, name, summary, and description. So here we need a to do object called as to do to be passed into as the parameter, but the to do has to be the request body. So we need to let Spring know that whenever you go on to /to-do and pass in a request body, that should be given to this method in the argument, and this should also be the request body. So for this, we have an annotation called as request body, which makes it really easy to actually pass in these. So let's import these now. So we import request body, and let's import request method, and we're good to go. So let's see, invalid, oh sorry, the value is equal to this. Yes. Yeah. And now all we have to do is call our service to handle the creation of the task for us. So we do a return to do service dot create to do, and we pass in the object. Now we haven't implemented our create to do yet, so we need to do that now. And just so we are clear about the controller, we have a request mapping where the method is post. So it's pretty straightforward, right? So we have a post method, we have the value as /todos, but will be having a request body to it. So the request body is a to do object which will be written in JSON, and Spring automatically converts it to a pure POJO. So we don't have to worry about that. And then we have a business service method here. So let's create that method now. So instead of object, we can have to do. So now here we will be implementing the logic for our create request. So we do a return to-dos dot add, and we add the to-do. So pretty simple, pretty straightforward for now, nothing complicated. And let's see what the problem is here. Oh, sorry, this is a void, my bad. And we don't have to return anything, we just have to create it. Yes, because the return value is void, we don't have to send. You can send in a boolean, so you can send in a true or false. So you can just check whether if it is successfully created, so send a true, or if it is not, and if it actually raises some error, then send a false. So we'll be adding a lot of validation to our request later in the videos, but for now let's see how a simple post request works. So here, all we have to do is add a to-do to our array list, and that's it, we're done with creating to-dos. So this is how you implement a post request in a Spring Boot application using the MVC framework. So let's refresh our memory and let's see what we have done here. So we have a controller, a to-do controller, which injects a to-do service, and the service handles all the business logic for our application. Next, we have the request mappings for the URL. So what happens when we do a /todos? We go to the method get all to-dos. We call the service method, which is a singleton. So the service method returns all the to-dos which are inside this. So 1, 2, 3. And next, we obtain one by the ID, which is a path variable integer ID. Then we go to get to do, and we have the logic here for it. The last thing which we do is create to do. So we do a create to do, and we just add the to do to our list. So let's run this and see if our post API is working properly or not. So for that, all you have to do is go to our to-do list and run as Java application. So the Spring has been released to the server and should be up in no time. So just give it a few seconds, and yeah, we're good to go. So now instead of using the browser, we'll be using Postman. So let's actually start using Postman now. So Postman is basically an API tool or a software which can help you handle APIs properly, so you don't have to worry about using something else. So now that we have our server running, we can send a GET request to to-dos and hit send. And as you can see, we get our we get our to-dos here. Now let's do a post request. So when we do a post request, we have to change a few things. So first we need to set the content type as JSON, which tells that we're going to actually pass in a JSON object or a JavaScript object. And here I have a body. So since we only have 3 tasks in our to-dos, let's add a 4th one, which is task 4, summary 4, description 4, and we press send. And we don't return anything, but we get the status as 200. So let's do a get and see whether we have actually added our 4th one. So as you can see, we have the 4th ID here. So that means the fourth to do was added to our list of tasks, and that can be confirmed with the body, which is returned when you do a get. And yeah, so that is how you implement a post API in your Spring Boot application. In this video, we'll talk about how we can implement the put and the delete request for our Spring Boot REST API application. And we'll see how we create the controller and also the service for this, and we'll run it on Postman and see what the output is. So just to give you a brief recap of what we have done in the previous videos, so we are making a to-do list REST API Spring Boot application where we have a to-do list API which we are going to create, which is going to have things like creating a task, updating a task, and deleting a task. So the CRUD operations that can be performed in a simple REST API, but using Spring Boot. So in the initial videos, we made our to-do entity where we had a simple to-do class, and we had the attributes or the variables for the class, which is ID, name, summary, description. We had generated the getters and setters, and also the parameterized and non-parameterized constructors. After that, we talked about how we can do a dependency injection into our Spring Boot application in the controller, where the to-do service is a singleton and how it works behind the scenes and all of that. And then we implemented a few requests. So we implemented 3 API endpoints, which is /todos, which is get all to-dos, and the other one is getting a single particular to-do based on the unique ID, and the last one is create to-do. And we also talked about how we just have an in-memory data right now, so we don't have a database yet, but the video after this will be starting our database journey. So we'll actually connect a database to our REST APIs, and then we'll be actually dealing with that. So in the upcoming videos, we'll also talk about how we can actually deploy our application on the cloud so that everyone and anyone can access it and use the API. So that is for later videos, but for this video, let's start implementing our put and our delete requests. So let's start with put first. So let's make our simple endpoint controller for this. So we just have a request mapping, and the method is going to be equal to request method dot put. So pretty straightforward, nothing different here. And the value is going to be equal to /todos /id. So only when we have the particular ID of our task, only then we can change it. So that is it. Next, what we have to do is make the method or code up the method. So we'll be having update to do, and now this will be having a path variable. So let's write that. Nothing extra here, just simple stuff which we have already done before. The path variable is going to be the ID, so the integer ID. Oh, sorry, my bad. And we'll also be having a request body where we have the updated things which you want to update inside our to-do, right? So request body, and that's going to be a to-do object called as to-do. Great, awesome. So now we have our method ready, and all you have to do is just like post, we just have a to-do call to the to-do service dot update to do and pass in our object. Now obviously this hasn't been made yet. The function update to do hasn't been made yet, so we'll have to code that up, but this is how the controller looks like. So pretty simple, pretty straightforward, nothing complicated here, exactly like post, but we have an ID and we have a request body. So let's implement update to do now. So create method, and this is our auto generated stub to fill in. So let's fill this up now. So how do we actually update our task, update our to do object here in this array list, right? So what we can do is, instead of doing a filter and lambda functions, all of that, we'll just do a simple for loop where we loop through each and every to do list object, and then we check if we have the one by ID. So we check by ID. So if the to do.id is equal to the ID inside the list, then we update, or then we set the object at that place, or we replace it. So pretty simple, pretty straightforward. If you know Java, that should be more than enough. But let's actually implement it now. So for int I equal to 0, I less than todos dot size I plus plus, and now we are looping inside. Let's get the todos dot get I, the index, and now let's check whether the ID matches. So if t dot get ID dot equals todo dot get ID. So if the ID matches, then we have to update our function. So let's see how that works now. So yeah, so I completely forgot about this integer ID, and I think the integer comes before to do. So let me just change that. Let me just fix this. Great. So let me see the to-do controller. So the controller has two, right? My bad, sorry. So we have the ID comma to-do. Great. So now instead of doing a to-do dot get ID, we just do an ID. So it's much easier to work with. Yeah. Now let's replace our existing to-do. Let's say 2 with the new object which we have. So all you have to do is do a todos dot set. The index is I and the element is to-do. And now that we're done, we return once that happens. So we're not handling a lot of exceptions and issues here for any of the REST APIs. We'll be doing that in the subsequent videos where we actually handle the cases where we are not able to find a to-do, so we throw a status 404 and also give a user-friendly message. So we'll be doing all of that in the upcoming videos, but in the initial videos, let's talk about the basics that we need to understand about how MVP architecture in Spring works, and also how simple API endpoints can be made without dwelling much into it. So this is how the update works. So update to do, loop through all of them, get each object, compare the ID, and then replace it with the new updated to do object if you find a match, and then return. And that's it for update. And now let's start implementing a delete. So delete is pretty straightforward, pretty simple, so we don't have to worry much about it. We'll just do it very quickly in like a few minutes, and then we can run the application and see our final a very simple hello world of CRUD right now. So again, let me just copy paste a lot of it here now. We don't have to write so much again. So we copy this again, and we just need to make a few changes. So this is going to be delete. Yep, and we don't need a request body because we just get the ID and we delete it automatically. And this has to be deleted. Yep, that's it. Let me just check request mapping, delete, and get it by ID, and then we just remove the ID. Great. So let's create the method in ServiceNow, and we got the stub. So again, the delete logic is pretty simple and straightforward, just like the update and the rest of them. We just have to loop through every single one again, and then delete the one which we get a match by the ID. So now that we have already done a for loop, let's do a lambda function again, because it's much more intuitive to do it with lambda function here, and you'll see why. So all you have to do is return. So, okay, we don't have to return also, we have a void. So we do a todos dot remove if, and we have a lambda function now. So for every to do object, remove it if t dot get ID dot equals the ID, and that's it. So since ID is unique, it will remove the ones which have the same ID. So again, if there's only one ID of one, then one is removed. So that's it. That's pretty much it. We just remove it if the ID is equal. So as I said, we're not doing a lot of, we're not handling a lot of issues and exceptions here because this is a very basic implementation, and we'll talk about or worry about them in a later video. So just to see what's happening here, we are assuming that the to do ID is unique, so we have to add that unique constraint here and the annotations, but we'll do that later. But the to do ID is later, then we remove it if there is a match, and that's pretty much it and how delete works. So let's run the application now and see if our implementation is right. So let me just run it before we actually use Postman. So run as Java application. And should happen about now. Yep, our laptop is really slow. I need to update it, but yeah, let's see what we can do about that. Great, so I think it is started on port 8080. So we have our, so let's get it first. So let me increase the size of this. Yeah, so let's get all the to-dos first. So we have 1, 2, and 3, task 1, task 2, task 3, and now let's do a put on 1. So let's do it on 1 now. We'll do a put body, it's going to be for 4. Okay, so we already have 4 here, so I'll just be lazy and do it for 4. So summary 4 updated, and description also updated. The header is going to be application content type JSON, nothing different there, and we need an ID. So the ID is 4. So we're updating 4, and we just update the summary and description. And now let's press send. We don't get anything here, but if you do a get on everything now, as you can see that, oh sorry, we didn't even have 4. Oh my bad. Yep, that was bad. Let's do a put again, and let's do it for 3 this time. Completely forgot that we do not have 4. Wow. 3, 3, and yep, 3. Great. So we're not missing anything now. Let's do a send and get all of them. Send. And as you can see, we have updated the third one. And now let's, while we're at it, let's delete 3 because 3 did not help us in any way. Anyway, yeah. So we have delete and to do /3. Press send. Again, we don't get a body back, but when you do a get again, you should see that 3 has been deleted. So yeah, as you can see, we just have 1 and 2. So this is how you actually implement a simple hello world CRUD application using Spring Boot. In the previous videos, we talked about and implemented how we can develop a REST API using Spring and Spring Boot. We talked about how we can create our CRUD application, which is create, update, delete, and we also wrote the business logic or the business service for it, and we also had our controller and our entity. So let's just see the API in action before we jump on to the next concept. So here we have our to-dos, and we'll just do a get request to see how it works. And yeah, as you can see, we have our 3 tasks here, which we already had here. So now, until now, we have only worked with a database or a list as an arrays list as database, right? We haven't actually used a proper real database where we can actually save our data. So in the upcoming videos and in this video, we'll talk about how we can actually use an in-memory database, something called as Apache Derby, and also talk about in later videos how we can actually use an external database, for example, MySQL, Oracle, or anything of that sort, any relational database. So in this video, we'll talk about how we'll be actually using those databases inside our Spring Boot application. And the way it is being done using Spring in Java is by something called as JPA or Spring Data JPA. So let's talk about what JPA is first.
So here I have a really nice blog post, which the link will be in the description, where you can actually learn about what is JPA, Spring Data, and Spring Data JPA in detail. And we'll actually be going through this little blog post and understanding what all of these are. So let's have some background. So as you know, in the last decade or two, the world of data has seen a big growth. So there's a lot of databases here which provide a fast processing mechanism and specialized storage. So we have things like graph databases, document databases, key value databases, and column databases, rows and columns. So SQL, NoSQL, all of that. And while none of these are a one-stop solution to store all types of data in a single application, we have something called as polyglot persistence, or basically you use the kind of database that is required for your specific type of problem. So for example, if you have a very big e-commerce website, so the data for all of your product list will be stored in a JSON NoSQL format, and the account information for each user will be stored in a SQL database. So in a single application, we can have multiple databases because each of them have their own advantages and disadvantages. So we make sure that we know what the advantages are. Now, previously, the way you used to use SQL databases inside Java was something called as JDBC, and JDBC was fine, but you had to write SQL queries manually for every single logic or every single source that you have, and that caused a lot of pain. So Java has created something called as a Java Persistent API, which is a JPA. So this aims towards bringing consistency around accessing different databases. So before JPA, as we said, we use the JDBC API to query them. With JDBC, we have provided native SQL queries, and we had to write those string representation of SQL queries, which was not only tedious but error prone. And obviously, the query syntax may change when you change your database. So MySQL and Oracle might have some differences in their syntax, and you'll have to manually change them or write the queries when you actually use them as your database. So now JPA is all about creating objects which can directly be mapped to the data objects. So the application will use JPA specification to push the object or retrieve the object from database, and this will be taken care all by the underlying JPA implementations. So we'll be using Hibernate in this case. So I'll talk about that later as well. So now this process of creating objects which can directly be mapped to the database objects, something called as object relational mapping, or OR. So with ORM, we use an API to query a particular database entity, and the result is provided in the form of a collection of Java objects. So you don't have to worry about how your object is being mapped to the database. The JPA takes care of that using something called as object relational mapping. So in our case, where we are building a to-do list API, we have a to-do object, and the JPA automatically map the to-do object with the database entity. So similarly, we just need to populate Java objects and pass them to the API, and the underlying ORM implementation is responsible for converting these API call into network SQL queries. So how that is being done, we'll be talking about that later, but let's first see what is Spring Data JPA. So Spring Data JPA is one of those many Spring Data projects which aims to bring consistency for all kinds of relational databases, be it SQL, Oracle, etc., etc. So now let's see what advantages we have when we use Spring Data JPA. So when we have a Spring Data JPA, we don't have to write a data access layer or any SQL statement at all, at least for the basic things which you need in our application. So based on the JPA specification, let's say MySQL, the underlying JPA implementation enables the entity objects and the metadata mapping. It also enables the entity manager, who is responsible for persisting and retrieving entities from database. So as you can see, the Spring Data JPA is handling everything for you in the form of an API, and it already has its own underlying implementations. For example, Hibernate, which deals with anything that you want to do with your data, and we'll see how that works in a minute. So the Spring Data JPA defines repository interfaces which have the methods for storing and finding entity beans from the database. So it already has the implementations and the interfaces that you need to actually build your database queries. Now, while the interface only defines the query method, Spring at runtimes provides proxy implementations for the defined interfaces. So you will not be seeing these implementations, but when you use the function calls, you'll know that how all of these work, which is pretty basic, pretty simple, pretty straightforward. Now let's see how this works. Let's see how we'll be actually using the repository Spring Data JPA inside our to-do application with the help of an example. So we have something called as query methods, and the name of the methods declared in the repository interfaces are actually converted to low-level SQL queries by Spring. So here we have a very simple example of an employee repository where the employee will be having to do some basic functionalities. For example, finding all the employees, find by ID, find by first name, last name, etc., etc. So now, as you can see, this is just an interface. There's no implementation which the person had to write for this. You just need the employee object or the class, and for our example, it's the to-do class, and later we first do a simple function call. So by Spring, by the interface, you have something called as find all. So the find all method will simply be select star from employees. So the find all method behind the scenes is converted to the low-level SQL queries, which is select star from employees. The second method pushes the where clause on the employee field, or find a select star from employees where ID is equal to employee ID, something like that. Similarly for the third and fourth one. So this is how we'll be integrating Spring Data JPA with our application, where we won't be having to actually write a lot of SQL queries or any SQL queries. We'll just be taking up or adding in some function calls similar to this, not exactly this, but similar to this. And you'll see that in very less changes in the code, we'll actually have a working database inside our REST API. So now, how does this work? Let's actually start. So before we end the video for today, let's actually make a to-do repository. So a repository is basically an interface. We'll be having an interface which actually will set up all of this for us. So let's go to do new class, and we'll be calling this class to do repository and finish. In this video, we'll be setting up our repository, the to-do repository, and we'll see all about the extra dependencies that we need to actually build up our database, and also the kind of database we'll be using. So let's get started. So first, this is where we stopped in the previous video. We had made a to-do repository, which was an interface, and now we'll be doing very little changes to this interface. We will not be actually writing any interface function calls here. We'll just be extending from a different repository provided by JPA, Spring Data JPA, and we'll just get right ahead into using it. So, but first, let's talk about the database which we'll be using for the next few videos. So, the database which we'll be using is called as Apache Derby. So, Apache Derby is an Apache DB subproject, which is an open source relational database implemented entirely in Java and is available under the Apache license. So let's see why we'll be starting with Apache Derby and not MySQL. So Derby has a very small footprint, about 3.5 megabytes, which is really less for the base engine, and embedded JDBC driver. So this is something which we value a lot, because it's very fast and it's very quick to actually have the database set up at runtime by Spring, and you just have to implement a service, implement a repository, and Derby and Java and Spring takes care of all of that for you. So we will be getting rid of that very bad arrays.as list function, right? So next, Derby is based on Java, JDBC, and SQL standards. So we will have Derby in a SQL standard, so we can assume that it will definitely have the SQL implementations behind the scenes. Now, since Derby provides an embedded JDBC driver, it lets you embed Derby in any Java-based solution, and that works perfectly, because if you not only have a Spring Boot application, but you have a Spring Boot application that's communicating with a different Java application, and both of them are running Derby, then having this will be very easy for you to communicate with the other Java applications, talk to them, and also have a very simple connection where both of them work at ease.
Derby also supports the more familiar client server mode with Derby Network Client, JD Driver, and Derby Network Server. This is something which is out of scope for this video or tutorial, so we'll not be looking much into this. But if you want, the link for this will be in the description, and you can definitely go ahead. And by last, Derby is very easy to install, deploy, and use. So this is also very important for our REST API tutorial, because we want to learn how to build APIs and make sure that the database part is being learned on the way. So now that we're new to Derby, let's check out the start page and see how we actually get into it. So we have a lot of examples, demos, how to use Derby with other products, etc., etc. And the first thing which we need to do for Derby is to actually have the dependency inside our pom.xml. So let's open up our pom.xml and let's add in some dependencies for ourselves. So the first one which we need, dependency, the first one we need is something called as Spring Boot Data JPA. So for that we need a group ID, and the next thing which we need is an artifact ID. Yep. Let me spell dependency correctly. Again. Great. So now we need to have the group ID and the artifact ID for Spring Boot Data JPA. So I have this right here already, so that we don't waste any time. So let me just pull that up. So here we go. So we have our Spring Boot framework, which is the group from which we need it. So let's go and paste it here. The next thing which we need is the artifact ID, which is Spring Boot Starter Data JPA. So this is the name of the dependency, which is Spring Boot Starter Data JPA. So this is something which provides you all the database function calls, methods, classes, interfaces out of the box, just similar to Spring Boot Starter Web, which helps you start a Spring Boot project with very ease. So this will be actually helping us setting up our CRUD repository, which actually will help you get started with how to use it. Now, the next thing which we need, the next dependency that we need is obviously Derby, Apache Derby. So let's actually add that now. So again, we need to have a dependency, and let's close this. Oh, sorry, don't add starters. And cool. So we need a group ID. And the next thing which we need is an artifact ID. Great. And again, we spelled dependency wrong. I don't know why I keep doing that, but great. And let's just copy Derby from here. So it's from org.apache.derby package. Let's go and paste it here. And the name is Derby. And we also have a scope, so let's just copy the entire thing and close this. So here we need this one. Yeah, so this is what are the two dependencies that we need to add to actually include Spring Boot Data JPA and Derby inside our application. And now that they are here, all you have to do is go to Maven and update project. And okay, so Maven actually gets the dependencies from the server and adds them to your Maven dependencies list, and you can use it. So now let's see how Apache Derby works. So the best part about having Derby or using Derby is that this is it. This is all you need to do to actually have Derby configured and set up in your application. So basically, what Spring does when you start the server, when you write all your when you finish setting up our database and writing all the function calls, etc., is that it looks at the POM and sees whether it has an in-memory database or an embedded database that it can use. And since we only have Derby inside our POM, it will assume that Derby is the one that we are using and set up and configure it for us at runtime. So that is how we take the how we use the power of Derby to actually build a Spring Boot application with the database. Okay, great. So now that we have our POM ready and we just need nothing else now, let's actually go and write some code to actually set up our repository. So as I said, we will not be writing anything inside the interface. We just have to extend from something. So it extends something called as CRUD repository. And let me just import it. And this will need two things in the implementation. The first will be what kind of repository are we wanting here. So it's a to-do repository. So we need the to-do class to actually for it to map the things in to-do. So let me just open to-do. So we need to map the ID, name, summary, description, all of this to our application, right? So for that we need to give it a parameter of to-do. And the next thing which we need is the data type of the unique ID which we have. So for here, the unique ID is integer ID, which is an integer. So we'll just put this as integer, and we're good to go. Now, we told the CRUD repository that the integer is the unique ID, but we haven't specified that here. So all we need to do is just have an ID annotation for our integer, and that will automatically take care or tell that this is an ID, which is by Java X persistence. Great. So what did we learn or what did we do in this tutorial? So we had imported two things. First was Apache Derby, which is an embedded database written by SQL Standard, which we'll be using later in the next upcoming videos. And we also added a dependency called as Spring Boot Starter Data JPA. After that, we set up our to-do repository where we extend from something called as a CRUD repository. So as you know, CRUD stands for create, update, delete. And this repository will handle all the interface and the implementation for all the function calls that we're going to make to, add a to-do, add a task, delete a task, update a task, or, add one task. And this takes in two parameters. One is the object, which we have, the single entity, to-do entity. And the next is the integer. So integer here is basically the data type of the unique ID which we're using, and in our case the unique ID is the integer ID. So we need to mark the ID by saying that this one is unique, which we do by the ID annotation. So now this shows that in our to-do entity, ID is the unique key or the primary key for this scenario. So this is all we have to do. In the previous video, we actually set up our to-do repository and we saw how that happened. We set up our to-do repository with the help of the CRUD repository, which is given by Java Spring Framework.data.repository.CRUD repository. We also added the ID annotation to our ID for the to-do entity. And one thing which we forgot to do in the previous video is that we need to tell Spring Data JPA that this to-do class is an entity, so that it can be mapped to the CRUD repository for all the function calls. So all you have to do is give it an entity annotation, and we'll just import this now. One thing which we missed in the previous video, and I think we have covered that now, so that's nice. Yeah, so in this video we'll actually finish creating our integrating the database, the Apache Derby database with our application, and then run it on Postman and see whether we can actually do some post requests, some get requests, some update requests, and delete requests. So this is going to be what the video is going to be about. So first, all we need to do is that we need to make sure that we have the repository ready. So we have the repository ready, and the to-do entity is also ready. So let's close these, and no changes in the controller. The controller is going to be the same, no changes. And all we have to do is work with the to-do service. So let's get rid of our list now, or get rid of our database now. And yeah, now the first thing which we need to do is we need to add a dependency, which is the to-do repository. So we need to auto-wire it. So auto-wired and private to-do repository to-do repo.
So let's import AutoWire. Great. So we have our to repository here, and let's see how we can work with this or how we can actually use this. So the first is get all to dos. So now to get all to dos, we need to actually return a list of to dos, right? So first let's make a list of to dos. So list of to dos, so to do equal to new array list, and yeah, we have created our list of to-dos. So now let's actually query our repository and see how we can actually use the repository to implement get all to-dos function. So let's see what a to-do repository gives us. So to-do repository dot, and as you can see we have a bunch of methods here. So we have count, delete all, exist, find all. I think find all basically says returns all instances of the type to do here. So I think find all works the best for our application here. So we'll do find all, and now that we have all that, let's add them to the to-do list. So for that we'll just use a simple function call again. So dot for each, and here we'll be using a different kind of Java syntax, which is to do's colon add. So this basically says that add for each to do which you find in find all, add them to the to do's list. So in this way we have filled up our to do's list, and all you have to do now is return to do's. And yep, it's that simple. So all we had to do was call the function find all. So we haven't even implemented find all. So as you can see inside our repository, let me just get the one inside our project, my bad. So to do service is here, to do repository. Yeah, so we haven't even implemented any of these interfaces. We automatically get the implementation from Hibernate, and we use them with the Derby database. Great. Let's see how if we can do something, if we can find something similar for get a single to do by ID. So return to do repository dot, and as you can see we got the first one as find one. So find one basically says retrieves an entity by its ID. So that's exactly what you want, since we have the ID as the parameter. So all you have to do is find one and the ID, and that's it. That's how we just return the to do which we get by the ID. And similarly, as you can see, we have a similar way of doing this for all the to do repository function calls. So again, let's return. Oh, sorry, we don't have to return anything here. We'll just do to do repository dot, not dot count, sorry, dot. And as you can see, let's try to find the one which we need. So we need a save. So the save basically saves it to the database. So we'll do save, and the entity is to do. And that is how we create a to do. So pretty simple, pretty straightforward, nothing complicated. And yeah, just make sure that I haven't covered all the edge cases here. So this is still prone to breaking. The API still breaks. So if you don't pass in a specific value, something, we just get thrown an error. We haven't handled exceptions yet, but we will do that in the future videos when we actually have an external database included in our application. So until then, we will be working with simple functions and assume that all the API calls will be syntactically right. So yeah, don't worry about that. Okay, great. So next is update to do. So as you can see in the previous implementation, we used this in a very tedious way. So we loop through all of them, then we get the one which we want, then we check the ID, and then we update it. So instead of all of this, a very simple thing to do here is just to copy this one and paste it here. So this can be done in multiple ways, but this is the way which I found very easy to do when I looked up online on YouTube and other blogs. So basically, the same methods creates the entity and also overrides it. So when you pass in your to do with the update, all it does is it automatically overrides your update and overrides the to do object which you have in database with the new one which you already assigned. So that's all you have to do to update your
to-do list or to-do task in your to-do list database. The next thing which we have is delete. So again, pretty similar. To-do repository dot delete and delete by ID, and that's it. So that's all we had to do to actually use the to-do repository and change the implementation so that this actually is being stored in a database and not an array list like we did before. So just to reiterate on the changes which we made for the database, we went to do service. So yeah, we have the import is never used. Which one? So yeah, so oh my bad, yeah, we don't need it if it's never used. Great. So now let's begin from the beginning. So first we made some changes to our entity. So we added the entity annotation so that Java X persistence or the database or the JDBC or JPA knows that we are actually using this particular class as our entity, which will be used for ORM, object relational mapping. The next thing which we did was create a new class or a new interface, which is to-do repository, which extends from TUD repository, which handles all of your hidden implementations for find one, find all, save, and delete. And it takes in two parameters to confirm. One is the to-do object, the entity which we have here, and the unique ID or the primary key of our entity, which is ID and integer. The next thing which we did was make some changes to our to-do service. So we added a dependency for to-do repository using AutoWire. Next, we made the changes inside our methods to make sure that we use the to-do repository function calls. And as you can see, it's very easy to read, very readable. Get to do is basically find one, get all is find all, create is save, update is also save because it overrides it and also creates it, and delete is by delete. So now that we have finished making our simple REST API with Apache Derby as a database, let's run this and see this in action. So let's go here and run our application. So here, as you can see in the console, you'll see the database changes happening and how Spring is working at runtime to give you the Apache Derby function mechanism. So as you can see, building JPA container entity manager, Hibernate is being used behind the scenes for the implementation. Schema ISL does not exist, so it's using automatically Derby, and we have started to-do list on 8080. Great. So let's post something first. 8080 will post ID task1 summary and hit send, and we get nothing in return, but the status is 200. Okay, so we have made it. Let's get and see whether it's did we actually make that one or not. So we do a get, and as you can see, we got our first one ready. Let's do another post. So let's do another one. So 2 2 2 and 2, and we post this now. Let's do a get to check whether this has been post. Great. Let's do a put and update it. So let's do task2 updated. Let me just do it for the rest, and let's do a send. Okay, now let's go to delete and let's delete the one which you want. Let's delete 2 and hit send. Great. So and we do a get again. So get for /todos, hit send, and we just have 1. So this is how we implement a to-do repository or a Spring Data JPA repository, and we use that with Apache Derby to actually implement the functions that we have here, which is find one, find all, save, and delete. In this video, we'll talk about how we can set up MySQL database with our Spring Boot REST API, and what are the changes that we need to do in order to get that external database up and running. So as you can see in the previous videos, we talked about how we integrate Apache Derby and embedded database inside our Spring Boot REST API application. And in this video, we'll actually move away from Apache Derby and actually integrate start integrating MySQL database into our application. And we'll see how easy it is to do that when you have a basic skeleton here. So since we were using the Apache Derby in embedded database, we wrote everything which we need to actually add some data into your database, right? So we have the repository interface, and we use that repository interface to extend from CRUD repository, and we also use that into our business logic and also the controller. So we have the skeleton we need to actually integrate any other database. So we'll be integrating MySQL, and in the upcoming videos we'll also integrate PostgreSQL to our Spring Boot REST API application. So yeah, let's get started. So in this video, what we'll do is first set up our MySQL applications, so the way we can write MySQL queries, and also check to see that everything is up to date. So in this video, we'll talk about how we can set up the MySQL database for our REST API, and in the next video, we'll actually integrate that MySQL database with our Spring Boot application. So first, I'm currently using a Mac OS. So if you're using a Mac OS, then you can just do a brew install MySQL. You're using Homebrew, and install MySQL on your laptop. If you're using Windows or Linux, then please make sure to follow, or make sure to ensure that you have MySQL in your system before you continue this tutorial. Next, so one of the best MySQL UIs which I like is MySQL Workbench, because it makes it really easy to write queries, execute queries, and also see a lot of things which we need. So MySQL Workbench is a unified visual tool for database architects, developers, and DBAs. So we come under developers, I feel. So SQL development and comprehensive administration tools for server configuration, user administration, backup, and much more. So if you're having a SQL database to hold account client information, or basically when you have a login system in your application, you can use this to see those queries and data in your system. The next is that it's available on all Windows, Linux, and Mac OS X. So since it's cross-platform, I think it works well with any OS which you're using. So since we'll be using the developed functionalities and design, so we can create our tables. We'll be doing that in a minute, and then we can also customize user privileges, so that once you're actually deploying your API, you know what to do. So let's go ahead and start with creating our database. So I have MySQL Workbench open here, and this is how the UI will be after initial login. So here I have a SQL query file. So I just write SQL queries here and then execute them. So the first query which we need to do is create a database. So let's do create database, and the name can be to do DB. So we'll keep it simple. The next thing which we need to do is use that database. So use to do DB. Great. And the next thing which we need to do is create the table. So let's create the table now. So create table to do. No, so we'll call the table as to do only, or listen to do. Yep, to do. And ID int not null, primary key, and auto increment. So just to make sure that we have all the right things we need. The next is title. Title, and it's going to be a varchar of 250. The next is summary, again a varchar of 250, and last is description, again varchar for, let's say, 500 now. So this is our a few queries which we need to know before we actually start integrating SQL. So what we did here is we created a database called as ToDB. Then we switched to that database, and then we created a table which has int
as the primary key, ID. So ID as the integer, title, summary, and description. So here, if you see our to-do entity, you will see that we have exactly the same. So instead of title, we have names. Let's quickly change that. So we don't need title, we need name, so that everything is right and all of the other things are good. So this is how we create our database and a table, and we'll be integrating this table with our entity. So we'll create an object relational mapping of this sorts with this table. And to make sure that the mapping is done correctly, we have the same column names as we have the class attributes. So let's run these queries. So for that, what you need to do is press Alt Shift and Enter. So let me just Alt Shift Enter, and this executes the query for you. So let me just show it to you. Yeah. Let's refresh all, and as you can see, we have our to-do-DB ready here. We have the tables as to do, and we have the columns as ID, name, summary, description. Great. Okay, so this is how you create your database, and the next thing which we need to do is play with the privileges a bit. So let me tell you what I mean by that. So first, let's write the query so that we get that out of the way. So we'll do flush privileges, and the next thing is going to be alter user. Let me just get this right. Yeah, root localhost, and we change the password to password. So one of the things which I noticed with my setup was that when I was actually writing the API, I didn't have any password set for root. So due to which the Spring Boot application was able to figure out where my database was. So that is why a very good solution, a very simple solution which I found online for Mac especially, is that you can just change your password to anything of what you like, and then use that in your application, which will actually help identify or get the database URL as soon as possible. So since I spent around I think like 2-3 hours wasting my time on how to figure out this, you can just use these two lines and you can just go ahead. And this, I think, is a problem with Mac OS users only. So anybody from Windows or Linux should not be facing this problem. But if you do, then this is a good solution for any operating system that you have. So make sure you flush privileges, and then you alter the root identified by your password. So for me, this will be password for now. And again, Control Shift Enter, and you have run those queries, and you're good to go. So now that we have finished writing our updating our database, what we can do is we can go up and start updating our application. So we need to first start with the pom.xml file and then work our way till the application properties. So we need a few things. So first we need to remove Derby Apache because we'll be using a different MySQL database, and we need to add a few other dependencies. So in the previous video, we talked about how we can integrate MySQL with a Spring Boot REST API application. In this video, we'll actually talk about the second part of the video of the MySQL extension, which is the changes which we need to do from the Spring Boot side so that we can connect the MySQL database server which we have with our Spring Boot application. So we won't be writing any code for this. The code will stay the same as it was for Apache Derby, and the only thing that changes is some application properties which are used to connect the Spring Boot application with database, and a few dependencies, one dependency that actually helps connect MySQL to our to-do object, which is the object relational mapping functionality. So let's get started. The first thing which we need to do is add the dependency which we have. So let's just type it out. And the dependency is going to be having a group ID, of course. So group ID, and the group ID is going to be MySQL because that's the database. And then we have artifact ID,
and the artifact ID is MySQL dash connector dash Java. Yeah, and just to give it a scope, just to scope runtime. Okay, so this is the dependency which we need to make sure that MySQL knows which class to use to create an object relational mapping from. So this is how you connect MySQL to Java. Okay, so now that we have it, we just need to do a tiny change inside our to-do entity class. We just have to tell this class that it is linked to a table in the SQL database, and the name of the table is to do, right? So let's just check the name of the table. It is to db and to do. Yeah. So once we do this, we see that we add the POSIX table import, and this tells MySQL which class to look at. So it'll scan all the annotations. It'll scan the table annotation, which is linked to the to do table inside MySQL. So this to-do entity is going to be mapped to the table. So yeah, just a quick change, or the only change in the code. Okay, so now that we have our dependencies and we have made that single change, let's actually go and delete this, and we'll just create it again. So we need to have a few properties inside our Spring Boot application, and these properties actually decide how we access and what kind of databases that we access. So this is called as you have already seen, application.properties. So let's create that right now. So application.properties, and make sure the spelling is right. Click finish. So this here you can override all the default settings by Spring, and you can have your own custom databases, custom build procedures, all of that. So let's write this to connect to our um, MySQL server. So since we have the TodoDB database or schema, so let's connect to that first. So we have spring dot data source dot URL equal to, let me just copy the address to the server, and it's to do db. Great. So the first thing is basically the syntax, right? Whether the syntax is actually correct or not. So I'll have a link in the description where you can see the official syntax for this. You know what is happening and why. So let's just see this for now. Yeah, no error. And next we need is the username and password. So let's just remove this and this. So we need the password and we need the username. So the username is root, and as I change my password to password, that is what I'll be writing. But obviously there are better ways to write this point. The next thing which we need to do is tell which implementation to use. So since we are using MySQL database and we're using the GPA repository, but we're using only an interface, we need to select which implementation do we want. So there are a lot of implementations for this, but the most commonly used is Hibernate. So we'll be using that. So we just add that piece of property here. So we'll be using the Hibernate MySQL 5 InnoDB dialect, and at a single time the max number of clients that we can have is 10, so that we don't max out on these when you're testing it rigorously. So now that we have the property set, so here we connect to the TodoDB MySQL database. This is how we connect the external database with our Spring Boot application. And once all this is set, all you have to do is just run the server again. So let's go and run the service, the Java application. Yep. Let's wait for this to run. So this is
establishing the connection, and so I think we got some errors. Let's see them first. What the errors are: could not create connection. Okay, let's see what caused that issue. So right here, let's go up. TrueDB is right. Yep. And Hibernate max full size 10. Now this is looking good as well. Let's see what the error was. So if you go to Spring Tool Suite and see the error, could not create the connection because that cut. I got to know what the problem is. So in our pom.xml here we need to add the version as well. So it's a version issue here. So let's add the version, which is 8.0.11, and just let go of the errors for now. So if these errors pop up here, all you have to do is ignore the warning for now, and let's run the application again. So let me just check the version again. Yeah, let me just check the version again. So I think, yeah, 8.0.11 should work. And let's run as application. And yeah, I think we're good to go. So the database is set up and the URL are also mapped, and we have the server ready. So I have already added nothing here, so let me just add some things. Go to post. Let's add two first, just for the heck of it. Okay, so now that two is added, let's do a get and hit send. As you can see, we get two back. So this is how, without updating any single piece of code, we're able to actually integrate SQL, MySQL with our REST API application. In this video, we'll talk about how we can update our to-do entity and also update our database so that we can know how do we handle situations where we have to update the database, add a column, or remove a column, or also make any changes in the database, and how the database changes should reflect our code and the entity changes. So first, let's get a recap of what we had done in the previous videos. So we have our to-do API. So we have the to-do service, we have the repository, we have the controller, and we have the entity. Now, the entity had ID, name, summary, description. So this is the four attributes which our to-do entity has, and this was controlled by our CRUD repository to make sure that we don't write any native SQL queries, and we talked about this in detail in our previous video. Apart from this, we also have our service, which controls all the business logic for our application, which is pretty much CRUD, so which is create, update, delete, nothing fancy here. And next we have a controller, which basically handles all of our API endpoints, so slash to do ID, and the put, post, delete requests of that sort. Now, all of this was initially handled using an in-memory database, which was basically a list, a simple Java list. Then we moved on to Apache Derby, which was an embedded database inside Spring Boot, and we were able to actually eliminate the list code using that. And after that, in our most recent videos, what we did was we had
an external database, which was MySQL, and we were able to connect MySQL to our database using the application.properties file. So we had this little file which had all the URL, username, password, and the properties which are required for a database to be connected to Spring Boot. So now in this video, we'll actually update or change our structure of our data so that we can see what places do we need to change so that these changes can be fitted into our application seamlessly. So the first thing which we need is that let's say I want to make this to do API access or being able to be used collaboratively. So suppose I have a to-do list and I want to send that to a friend of mine, and I send that to a couple of friends. All of us collaboratively work to solve or to finish that to-do list, and there should be an author of all of that to-do list, right? So let's add an author to our entity. So we have string author, and let's make our changes inside our constructor. So we need to add author here, add an author here as well, and the next thing which we need to do is make getters and setters for this. So we need to do a public string get author, which returns author, and now we need a setter. So public void set author, and all this does is instantiates our author. So pretty straightforward, nothing complicated as of now. We just added the author attribute to our to-do entity. So what's the problem here? Yeah, sorry, string author. So we just added the author to our to-do entity, nothing different, nothing complicated here. And as you can see, we don't have any other changes to be made. So if you see the controller, we are not explicitly accessing the to-do object and the attributes inside them. So here we just handle the to-do object as it is. So the object inside consists of all these attributes. So nothing explicitly handled in the controller, nothing in the repository as well. We just have the entire object and the integer, which is the ID. And for to-do service, we also have nothing explicitly being handled. So only change we had to make was inside here, and we are good to go. So this is the change which we had made from the core or the API side, and now we need to make the same change in the database, right? So open MySQL Workbench and make sure that you're connected to your root and have the to-do DB ready in your schema. So now we need to alter the table to add that column, right? So we do use to-do DB so that we'll be using the to-do DB database, and let's write the query. So it's alter table to do and add author. It's going to be a var char of 64. Yeah. So this is our query. So let's run the query now. So all we are doing is altering the table to do. We are adding author column of varchar 64. So let's just do a run and let's refresh our schema. Let's go inside tables to do columns, and as you can see, we have our author ready. So now that we have an author ready, all we have to do is basically run our function, run our API. So let's run it right now. So we have initialized our entities, we have mapped the URLs here, and our API is started. So let's go to Postman and let's do a get first. So let's just do a small get and see what we already have inside. So I'm doing a get. Let's see what we already have. So first we have just one here. We just have a to do of task 2 with author null. So the author has been added now. Let's do a post and have a body. Let's do an ID 3
task also 3, summary 3, and the author is going to be me, so Ronak Vyas. And let's just do a small post and see if that works. So the status is 200. Okay, so I think we executed that. Let's do a get and see what happens. So we do a get and hit a send. Yeah, as you can see, we have added the author as Ronak Vyas. So that is how we actually make changes to our database and also our REST API. So first you need to make the appropriate changes inside your Spring Boot application, and then once that is done, you can make changes to your database. So usually you make the changes to your database to your Spring Boot application first, because suppose you're working with a lot of people in your team, and everybody in your team is working on the same code on the same database as well. So if somebody is trying out a new feature, then the database is currently being used. So if you make a new column and then alter the database and add a new column and then start working on your code, somebody who is working on a different feature will not be able to actually access your database, right? Because you have a new column which the person does not know anything about, because it's a different feature altogether. So what my suggestion is that first work on the code, make sure that the code is up to the point where you're confident that you can actually make changes to your database now. And once you're confident, then make the change to your database and just let everybody know that I have made this change in your database, and you need to use this so and so and so, and keep working. So in this video, we'll talk about how we can integrate PostgreSQL with our Spring Boot REST API application. So the usual way of doing this is by first downloading the PostgreSQL database, and which you can do it on this link. And once it's done, make sure that you have a PostgreSQL UI from which you can actually add and remove your tables, add database, etc., etc. So I will show you what you can do to actually download this and how to also download the PostgreSQL UI. So I currently use a Mac. So for that, I use a Mac OS operating system and I download the package. Once it is done, PostgreSQL gives you a very nice and handy UI using which you can actually spawn a terminal of your own for each and every database which you have, and then use that to actually use your PostgreSQL database. So let's get started. The first thing which you need to do is download PostgreSQL, and once you're done, let's open it up now. So it's the Postgres app, and yes, check automatically. And as you can see, my server is running now, and you'll get PostgreSQL by default as a database and also a template one. So first, what we do is click on template one. So let me just take this one as my database, and just to show you what happens. So once you click on that, it opens a nice terminal. So let me increase the size of the terminal. Yeah, so I'm inside the template one database, and if you want to see the tables inside now, you can see that there are two tables, to do and to do, which I've made, but we'll make another table using which we'll be integrating our Spring Boot REST API application. So this is how the terminal looks, and make sure that you have PostgreSQL downloaded and installed before you start the video. So yeah, now that we have our PostgreSQL database, the next thing which we need to do is make sure that we update our application properties, because this is where the major changes of our application are to be done. So if you are new to this video and new to the Spring Boot application REST API videos, then make sure to watch my playlist on this channel, and I'll just give you a quick overview of what is happening in this REST API application. So this is a to-do list API, and you have a to-do entity here, which is going to be using these attributes. It's going to have an ID, title, summary, description, and all of the stuff, setters and getters, parameters, constructors. This is then controlled by a to-do controller, which has the API endpoints for our to-do list API. And the business logic resides in to-do service, which has everything from get all to-dos, get to-do, create to-do, etc., etc. And the last thing is the repository, which handles our implementation for JPA, in this case Hibernate. So we'll be using this to actually make sure that we have our basic implementations for save, find all, etc., etc. Ready. So this is how our API is in a nutshell. So the first thing which you need to do after you have installed Postgres is first have the Postgres SQL dependency. So this is the dependency here, and just install it. Remove the Spring MySQL dependency that you have. Just make sure you have Postgres SQL, and should be downloaded within no time. And then right click, go to Maven, and click on Update Project, and it will automatically have it in your Maven dependencies. So when that is done, the next thing which you need to do is change the dialect. So dialect is basically how Hibernate implements its native SQL queries for you. So the Hibernate dialect for PostgreSQL is this. So I'm just copy it from here. I just did a Google search for this, nothing complicated, and just paste it here. Great. The next thing which you need to do is change your URL. So let me just do this for now. We don't need the username and password. We just need the database location. So let's see how you can generate a PostgreSQL. Yeah, right here. So this is how it looks like, your PostgreSQL URL. So we need JDBC. So JDBC is your API which connects it to your application. And now that we have done this, we need to go into template 1. So template 1 is our database here, which we are accessing using this terminal. We are template 1. Okay, so now what we have to do is create a new table. And let's say the name of the table is going to be to do table. Not the best name, but we'll make do for now. So now that we have a to do table name, so let's do it to do table. We need to make this table inside our template 1 database. So for that, what we can do is we can do a create table to do table, and then have all of our attributes. So first we have is the ID. So ID int primary key. Next is going to be the title. So title varchar 64. The next thing is summary varchar 64, and the last thing is description varchar, and it's going to be 64 as well. So these are all the attributes that we have inside our to do table, and let's hit enter, and you see that it has created a table. Just to confirm if the table has been created or not, let's do a /gt. As you can see, you have a to do table as your table inside your database. So now that we have made our to do table inside it, make sure that the name is also the same here to map it to your object, which is called object relational mapping. This is ready. The form is ready. We don't need the controller now, and all you have to do is now run your Spring API, and let's see that it has actually started our implementation of connected PostgreSQL successfully or not. So as you can see, this server is spawning up. No errors so far, so we are good to go. And yeah, we have started the to-do list server. So now to check whether our database is working or not, go to Postman, do a get of to-dos, which would give us an empty list for now. So as you can see, an empty list. So let's add some data. So do a post body. I will give it as 1. Let's have the task as do lead code every day, or let's just make it a bit funny now. 1 lead code a day keeps unemployment away. Great. The summary is going to be invert a B-tree. Description same as summary, and we don't need the author for now. So this is how our ID is, and let's post this now. So do a send, and the status is 200. Okay, so let's do a get, and we should be getting our data back. So yes, I think I missaid the title a bit, but this is how you actually connect your PostgreSQL database to your Spring Boot application. So let's rewind and see what we did here. The first thing which you need to do is download PostgreSQL for your operating system. After that, open it up, you'll be having PostgreSQL, and then if you want, you can initialize a new database. Make sure you double click on that and then connect to your terminal. Increase the font if you want to because it's really, really small. And once that is done, you can then create a table here as I did. Go to your application properties, change the dialect and also the URL, and you're good to go. So that is how you integrate an external database as PostgreSQL into your Spring Boot application. In this video, we'll talk about how we can integrate caching in Spring Boot using Caffeine in-memory cache, and we'll also look at what caching is, why do you need a cache, and how can a cache actually speed up or increase the performance of your application through various approaches. So before we move on to how to implement a cache and looking at an example, let's talk about what caching is. So this blog post by AWS on caching is a really nice starting point to understand how caching works. So please check it out, and I'll have a link in the description as well. So in computing, a cache is a high-speed data storage layer which stores a subset of data, typically transient in nature, short-lived, so that the future requests of that data are served up faster than it is possible by accessing data's primary storage location. So what does this mean? So let's say that you have a very expensive data object in your database, which when you fetch it from database, it takes a lot of time. So what you can do is you can use a cache where you only fetch that expensive object once, keep it in the cache, and in the future requests, the data will be served through the cache and not by the database. And the cache is in memory, so it'll be really fast to actually get that expensive object from to your application. So how does caching work? The data in a cache is generally stored in a fast access hardware such as RAM, and will also be used in correlation with a software component. The primary purpose of a cache is to increase data retrieval performance. So this is very important. To increase data retrieval performance by reducing the need to access the underlying slower storage layer. So in our example where we had an expensive object inside database, our slower storage layer would be the database, and we use an in-memory cache to actually increase the data retrieval performance. Now, the next thing which you need to know is the benefits of caching. So we have an improvement application performance, reduce database cost. So this is what we'll be looking at. Reduce the load on the backend, increase throughput, eliminate database hotspots, and predictable performance. So when you use a cache inside your application, whether be it to cache the application, cache the load balancing, cache the database, you will see a very nice increase in your performance and scalability. And of course, this also depends on different factors of your application and also the kind of configurations you have with your application. So now let's actually look at how we can implement an in-memory cache in Spring Boot using Caffeine. And if you want a really thorough example, then please go through this blog post where they explain how you can implement a cache in a REST API. But we'll be looking at a very simple example, sort of a hello world of caching using Spring Boot and Caffeine. So let's jump into that. So yeah, before we start going to the example, you definitely need these two dependencies in your application. One is Caffeine and the other is the Spring Boot Starter Cache dependency. Okay, so here I have a very simple application which uses a cache, and we'll go through this application, run the application, and see how the cache is being implemented here. So if you want to know how to write the code to implement a cache for your application, then there are a lot of tutorials on YouTube where you can actually see how to implement it. This one deals with understanding the cache and how the configuration and how the system works in Spring Boot. And we'll be using the Caffeine cache as an example here. So first we need to configure our cache and add it to our cache manager by Spring Boot. So this is what this code does, or config file does. Here we have a Caffeine which we are building. The initial capacity is going to be 100, maximum size can be 500. The element in the cache expires after access in 10 minutes. So if it's been more than 10 minutes since the last time the limit to the cache was accessed, then it automatically expires. And you have the record stats method, which basically gives you the statistics of your cache. For example, the eviction count, the hit count, etc., etc. So this is how a configuration for your cache config works. The next thing which you need to do is two things. First, we need to enable caching for our application. Tell Spring Boot that we will be actually using a caching mechanism inside our application. And the second thing is pointing to which method will we be caching, and we have to tell Spring Boot that. So let's see how we do that in the application. So Spring Boot has an annotation called as enable caching, which you can add to your application or even to your configuration file. And this tells Spring Boot that please look at all the dependencies that involve caching in the class path and use the ones which you specify. So we have specified the caffeine cache here, so we'll be using that and searching for caffeine dependency in the class path. So we have that in our POM. Let's just look at that here. Yep, we have it right here. So this is how we tell Spring Boot that yeah, we want to enable caching for our application. The next thing which we need to do is tell Spring Boot which method to be cached. So here I have an example service which basically gets you a string and it tries to simulate an expensive DB fetch or database fetch and return the string back. So you can think of this as an example where we are fetching a really expensive object from the database and then returning it back to the user. Now, since this is going to be expensive, we add a cacheable annotation on top of it, and now every time we access this method, the return value will be added to a cache, and this cache is in the form of a hash map or hash table which has a key value pair, and the value inside your cache is going to be the return value here, which is going to be a string. The last thing which you need to know is cache config, which is basically the name of the cache which you want to use. So if you see the config here, we are using an example cache, which is the name of our cache, and we just point out to Spring Boot that this is where we actually want to use example cache. So now when we actually test our application, we will see that this line of code will only be seen once, because once we fetch it from the database, it will be inserted into the cache, and then we will only be getting this result without actually going through the DB calls inside this hypothetical method. So now let's see our actual method where we try this out. So we have AutoWire or injected our example service. We start the caffeine cache testing process. We call the get string method, and since it's the first time, there is no hit to the cache. This is a terminology where we use for caching. When we actually access the cache, it's a hit. When we don't access the cache, then it's a miss. And when the element is removed from the cache, it's called eviction. So the first time when we do this, it will actually hit our database, and this will be printed out. From the subsequent times, here we have a hit, so this piece of code will not be shown again. So let's see how this works, and we can run it here, and we are looking for this to not be there inside our application. Should be the only ones. So let's do it here, and as you can see, we have the simulating log only once, and subsequent times we just call the expensive string inside our function. So this is how you implement a very simple introduction on how a caffeine cache works in Spring Boot, and how you can actually run this code and figure out how to use caffeine cache or a cache inside your own application. So that is all for this video. The code for this example will be in the link in the description, the GitHub repo. You can definitely check it out. Thank you for watching, and I'll see you in the next one. Let's get started. So in this playlist, we'll talk about a very important, a very good framework called as Quartz. So Quartz is an open source job scheduling library that can be integrated with in virtually any Java application. So it can be a smallest standalone application or can be a part of a very large e-commerce system. So quads can be used to create simple or complex jobs, even tens and thousands of jobs, and these are defined as standard Java components that may execute virtually anything you may program them to do. So in our playlist, in our situation, we will be scheduling emails, and we'll be having an email job which will deal with taking up somebody's email, the subject and the body, and scheduling them as per we need. So you can have an email that is being sent out when a person has their birthday. You can send out a birthday email, or if you want to send them or remind them of something, you just schedule that as a reminder for somebody else. So this is a very good way to learn about how Spring Boot works with other variety of frameworks, Quads being a great example. And we also learn how to actually build a real world example of what we are learning when it comes to concepts. So, in this video, we'll learn how to schedule jobs in Spring Boot using the Quad Scheduler by building a simple email scheduling application. The application will have a REST API that allows clients to schedule emails at a later time. We'll be using MySQL to persist all the jobs and other job related data. So this is the timeline for the videos. So we have our first video, which is the introduction of Quads and creating the application. Next, we have configuring the MySQL database, the Quad scheduler, and the mail sender framework. Third video is going to be about creating Quads tables. So Quads has a set of tables by themselves, which they use to manage the data behind scheduling a job. So we look at that. Next, we talk about some basic terminologies which Quads has to offer, such as job data map, job key, a query job descriptor, a trigger, and so on. Next, we start building our application from video 5, where we first create the request and response payloads. What information do we get from the user, the JSON, and what do we actually show them as the response. Then we'll be creating the controllers for scheduling email. So a schedule email, update email, pause or resume a schedule, and so on and so forth. Next will be a controller for getting the emails, following an email scheduler service, which is basically the heart of our application, the email job, which is going to be what you actually want to send in the email, and finally we'll be running and testing our entire API in the final video. So this is what we have in plan for the upcoming playlist. So make sure that you follow through, you watch all the videos, and please let me know if you have any doubts in the comments below. So let's get started. The first thing which we need to do is go to spring.io, start.spring.io, where we basically initialize our application using their web interface and directly start with a predefined project. So we don't have to worry about a new project, creating them from scratch on IntelliJ, etc., etc. So go to start.spring.io, give it a new artifact name. So you can just say email scheduler, and we need to add a few dependencies here. The first dependency is going to be web. Second is going to be JPA. Third is going to be Quads. Next, we go on to MySQL, and finally we end it with Java Mail Center. So these are all the dependencies that we need to actually start creating our email scheduler application with its REST API. So next, click on generate, and it will create a zip file or a compressed file which you can extract on your local machine, and then you can open it in your favorite IDE. So in my case, I'm using IntelliJ IDE for Mac, but any IDE which supports Java, Spring, and Spring Boot should work here. So this is the IDE which I use. It's free for Mac OS, free for Windows as well. You probably have a 30-day free license, so you can use that for this video and the upcoming videos. So let's get started. So once you have created your Spring Boot project, you have to open it in your schedule in favorite IDE, and you can see a project live here. So here, when you can see, if you go to source main Java, we already have a starter project ready in front of us, which we can directly start and see how it works. Next, we have our pom.xml, and here we have our dependencies that we need. So we have our JPA, we have our mail, Quads, and web. Give it a good description. So quad scheduler or email scheduler. We can add an email scheduler for using quads, and you have a very simple project ready to make your first scheduler using quads. So in the next video, we'll talk about configuring MySQL database, quad scheduler, and mail sender. So this will deal with the application properties of our application, where we add the server URL for MySQL database. We add some interesting configurations for quad scheduler, basically how it works, the ins and outs of quads, and also the mail sender. So we'll be using a framework which helps us schedule mail via code. So we need to also talk about some settings from Gmail, which we have to allow so that we are able to actually make SMTP calls from our code to the Gmail server. In the previous video, we talked about setting up a very basic Spring Boot application, which you can see here on the screen. It has a very simple starter, which just has a main function and runs the Spring Boot application. And we also now need to set up our run for configuration for our app. So in IntelliJ, what you can do is go on to this little piece of information, go to edit configurations. Now you need to select an application called as Quads Runner and then run it. If not, you can also use the Spring Boot's way of running the application, but I would say the application way helps you to understand how Quads or how a Spring Boot application works behind the scenes. So all you have to do is, let's do it again. So we do a plus application. We can give it a name as Quads email runner, running it on local machine. The main class is something which we need to talk about. So it's going to be quad scheduler application, and that's it. So that's all you need to have your runner ready, and you can always just run it whenever you want to. So that it gets easier to have a runner ready. You don't have to always click this. You can always click it here or the debug mode and then have your application running. So coming to this video, we'll be talking about the configurations or the properties that our application needs to set up quads, to set up the database, and also to set up our mailing properties. So we'll be using an email ID to actually send the emails, right? Or to schedule the emails. So we need to also set up some properties there. So let's get started. So go to resources and to application.properties. This is where basically we have all of our applications ready and the properties. So now what we're going to do is have them write the application properties for our application. So first comes the Spring data source. So the Spring data source is basically the database which will be connecting to your Spring Boot application, and some information regarding that, which includes the URL, the username, and the password. So let me write the ones for mine. I will not be giving it the values for now. I'll be doing it in the next video, because the next video is going to be dealing about configuring our database and how we can set up our MySQL server and integrate it with IntelliJ. So spring.data source.url, spring.data user name, and we can do spring.username.password. Now it is generally recommended that you do not have your password in plain text when it comes to enterprise applications or projects that you're deploying on, let's say, GitHub or anywhere else. So just for now, for practice purposes, we'll have our password in plain text. But if you're using this to create an enterprise application, or using it to create or deploy it on a provider or on GitHub, then make sure that your password is not there in plain text, and it's modified or hashed in some way or the other. So this is the these are the properties that we need for our Spring data source, which is going to be a MySQL server, which we talk about in the next video. The second thing which we need is the Quartz properties. So let's start writing them. So the first is going to be Spring dot Quartz dot job store type. Now, as you can see, these have two options. One is JDBC, which we are going to use, where it stores your jobs in the database. The upside or the advantage of this is that whenever you shut down your application, then restart it again, it takes up all the failed jobs, or it restores the jobs from the database and then runs it again, so that you always have that job running. It's never in the failed scenario unless something happens from the user point of view. Next is storing it in memory. So this is basically a way of Quartz to store your jobs in memory only, not inside external database. So whenever you shut down an application and then run it again, the jobs get destroyed, and then new jobs have to be created whenever you restart your application. So since we need our jobs to be persistent and to be inside a database, we'll be using JDBC method or the value. The next is the thread pool count. So the Spring dot Quartz dot properties arg dot Quartz dot thread pool dot thread count. Maybe 5. So this is basically the amount of threads that you want your application to use when it's scheduling its jobs. So for example, if you have 2 or 3 jobs which are scheduled for the same time, you can have 5 threads in which each of the thread will have its own job running at the same time, so that it's less load for the application and for that particular thread. So next comes our mail properties. So since we'll be scheduling our mail, scheduling our mails, we'll have to have an email from which we send it from, and we also have to tell it what the protocol is, what kinds of things are we using. So let's add them. So the first property is the host, and since I'll be using Gmail to showcase the demo, I'm using Gmail Simple Mail Transfer Protocol, or smtp.gmail.com. So the next two properties are the port and the username. So port is basically the port in which you would want to send the mail through. So for here I have 587, and the username is my email ID. And you can also email me on this email ID if you have any doubts regarding your resume, if you want to talk about your cover letter, how to get jobs, how to get a software engineering job later on. So this is the email which I use. And next is going to be the password. So I will not be writing that here, but again, you should not have your password in plain text, but you should have them hashed. So Spring dot okay, so these are the basic properties that you need to make sure that your application has enough it needs to build up the email scheduling app. The next thing which comes in is two I would say necessary properties, one being the authentication and the other being start TLS. So we'll have that for now, and I'll talk about them later in the upcoming videos. So let's just input those properties now. So with these properties, now we have our application ready to start building it and then schedule jobs and schedule emails. But before we do this, we need to have an additional step which we need to make sure that we are doing, so that we have our emails which are actually being sent to the receiver. So since we are using Gmail by default does not allow you to send emails through a less secure application, and since we have literally no security in our application, it will be hard for us to actually let Google send our emails, and we'll just prohibit it or mark it as spam or just not send them. So what we need to do is go to this URL. So the URL will also be in the description below, and scroll down. So this is the security part of Google's account. Scroll down to less secure apps, and you should make sure that you turn it on. So you can click here when it says turn on, and then click it to turn on, and make sure that you do this only after reading what's happening here. I do not recommend this, it's just something which I have done. So make sure that this is turned on if you want to use the smtp.gmail.com for your particular email scheduling app. We talked about the Spring Data Source, and we'll be talking more about this and also setting up our database. Next is the Quartz properties, where we talked about our persistent jobs, where we store the jobs inside the database, and also the thread count, which is basically how many threads would you want in your application to run your Quartz jobs. Next was the mail properties. We talked about using the smtp gmail.com host and having a username passwords ready, and also making sure that you have turned on allow less secure apps to use Gmail, so that you can actually send emails from your Spring Boot application to the recipient. Now in this video we'll talk about how we can configure our MySQL server and connect it to our Spring Boot application. So first you need to have MySQL on your local computer. So I'm currently using a Mac, so for a Mac I would suggest installing MySQL using Homebrew. So this particular link, which will be in the description below, will tell you how to install MySQL using Homebrew, and then you can start your services with just one command, which is this one. So using brew services start MySQL, you'll be able to start your MySQL server immediately, and then you can use it to create your databases. Okay, so now that you have you are ready with a MySQL server, let's go and start working on it and creating our database. So again, if you would like to set up your database using IntelliJ, you can use it via this, or we can use something called as MySQL Workbench. So MySQL Workbench is basically a GUI application for your MySQL server, and we'll just create a database here, and then we'll move on to using the IntelliJ database settings. So let me just create a database here. So as you can see, I have created my database, and if I refresh the schema, you can see Quartz demo right here. Now that we have our database ready, let's actually go and have it inside our IntelliJ application. So we can close this off for now and go to databases. Let me just delete this so that we can create it again. So remove. Okay. And let's go to plus data source MySQL, and giving it a name as Quartz demo. Now what we need to do is add our URL link. So the URL link is going to be as follows. You can almost use the same URL link. So let me just copy it and then show it to you. So MySQL server is running on localhost 3306. So as you can see here, so let me get this back, demo, and just paste the URL as it is, and it has a /Quartz demo because Quartz demo is what I'm using. SSL equal to false, allow public retrieval key true. So this is something which we'll talk about later, but it's important to have it here for our database to work.
My username is root and my password is also root. So let's test the connection real quick so that we make sure that our database is connected to IntelliJ. And yep, succeeded. So as you can clearly see, we have our database ready. Click apply and you do an OK. So as you can see, we have our database ready here. So our SQL Server here, Quartz requires us to create some of the tables using their SQL script, which they have. So the next step here is going to be using those scripts and running them here inside our MySQL console. So go ahead to this URL, which is again in the description below. And this is something which is given by Quartz itself. So all you have to do is copy the entire SQL list and then just exactly paste it inside your console. So I'm going to do that right now. I can just do it a raw. Do Command A, Command C, or Control A, Control C, and just paste it here. So let me do it here. Yeah, and these are everything which Quartz requires you to have. So don't worry about this. You can go into this later, or you can see this later. So just make sure that you have this ready. And yeah, so if you want this in your Quartz file, again you can add this to your Quartz file. So let's do that as well. And great. So now we have this ready. We have our console ready. Also, let's just do it without this so that we just make sure that we are not missing out on anything. Yeah, now all you have to do is run this. So we'll just click on run. And here you'll see how it's being run. So we can wait for some time. You can also view your database creation of tables in the database. So we'll do that in a minute. Let me just show it to you here for now. So that green tick shows that all of these queries have run. So let's wait for it to run all the others. So as you can see, all of them have been running. So we have finished creating a database. And to check whether the tables have been created or not, go to database, go to Quartz demo, and as you can see, we have all of our tables here ready. So if you would like to see what's inside the tables, let's look into that. So first we have our job details. So yeah, before we get into all of this, let's actually understand the terminologies which we need to know in Quartz. So here we have an overview of Quartz scheduler APIs and terminologies. Again, this link will be in the description below. So first we have the scheduler, which is the primary API for scheduling, adding, removing jobs. We can pause the jobs, resume the jobs, all of that. So it's the primary API or go-to API when it comes to dealing with Quartz. Next is a job. So a single unit of work which your application is going to do. So in our case, it's going to be scheduling the email. That is called as a job, and it's an interface to be implemented by the classes that represent a job. So you will be implementing the job class, and then it has a single method called execute, which you'll be implementing, where you write the work that needs to be performed by the job. Next comes in the job detail, which represents an instance of a job. Also contains additional data in the form of a map. So you have a key value pair, and then you can add some primitive data types as in that map. So we'll be having our from, to, subject, body of the email inside this particular job data map. Every job detail is defined with a job key, which is again consists of a name and a group. So this makes every job unique, a name and a group. Now next comes a trigger. So a trigger is basically when do you want your job to be triggered. So it defines the schedule at which the job will be executed, and a job can have many triggers, but a trigger can only be associated to one job. And similar to job detail, every trigger is identified by a trigger key that comprises of a name and a group, which again has to be unique within a group. Next we have a job builder and trigger builder, which is basically a way of creating job detail instances or creating trigger instances. So this is all you need to know about the terminologies in terms of quads, and all of them are fairly straightforward. Once you work with them for a few minutes or so, then you'll be very comfortable with them. And now we can go ahead and see what's inside our tables. So the job details tables has the scheduler name, which your local scheduler will be using, the job name, job group, description, job class name. So in our case, it's going to be email job, whether it's durable or not, whether you can update the data or not, and the job data which it has inside it. The next important table is the quads trigger table, the name of the trigger, name of the job it's associated with, and priority, next fire time, previous fire time, when it's going to get fired, and the trigger state, which tells you the state in which the trigger is. It's acquired, waiting, running, all of that. So the other tables are also important, but you will mostly be dealing with these two particular tables. And this is how you actually integrate your quads tables inside a database, connect your database to a Spring Boot application. We talked about setting up our application.properties, where we set up the database, data source, URL, password, JDBC connection, SMTP, etc., etc. And in this video, we'll talk about creating our API. So we'll talk about how to can actually create a REST API, which will help us schedule those jobs, and then we will schedule the jobs using Postman. So in this particular video, we'll talk about the DTOs, or the data transfer object, that we'll be using to communicate with the user and quads. So let's get started. So first we need a new package. So let's go here and create a quad scheduler dot payload. So this package is going to consist of the DTOs. So we have a request DTO and a response DTO, and these DTO will talk to the user about the type of values that are needed to be entered. So for example, the email, or the subject of the email, the body, date, time zone, etc. So we'll be taking up this request from the user and then scheduling our emails via quads. So for that, we need to have a DTO, or a way for the data to be transferred from the user to our application server. So let's create a Java class called as email request. So now we need to add a few fields for our attributes for our class email request. So let's start with the most obvious one. So we have @email and @not empty. So these annotations make sure that our email, so private string email, make sure that our email is always in the form of an email and is never empty. So we just have to make sure that we have the right classes for that, so that we don't have to worry about the validation which has to be done on email, checking whether there is an @ or there's a .com or .n. So all of that is being handled by the email annotation. And yeah, of course, our email cannot be empty, so that's why we have a not empty annotation on top of it. Next is going to be the subject. So the subject also cannot be empty. There are emails which are being sent without subjects, but those are usually marked as spam, or they're not trusted. So we'll make sure that our application has a subject, again a private string subject. So next up is the body. So again, we don't want an empty body, so we'll make sure that a body also is not empty, and this is going to be body. Next comes in the date time. So the date time at which the email was sent, and for that we have not null, so it's different, and private local date time, we have the date time. And let's keep importing our classes as we go. Next up is the zone ID, or the time zone of the current place you're in. So if you're sending an email from India to, say, let's say Europe, then we have to have the appropriate time zones mapped at both the places, and this particular field takes care of that. Again, this cannot be null because this will be there for all the emails that you sent. And private zone ID time zone. And yeah, so this deals with the email request, or the request which the user sends to the server.
and this will contain the email to the sender's email. So for example, if I'm sending it to test@test.com, then that is added here. Next is the subject, which is the topic of your email. Next comes in the body, the date time at which it was sent, and the time zone from which it was sent. So this is basically what is going to be inside our email request. And let's add some setter and getter functions here. So we'll do a setter, and we'll also do a getter. So make sure that you download the Lombok LOMBOK plugin from here. So just go to files, sorry, not files, I would say go to preferences, and let's wait for it to come up. And here go to plugins and then download Lombok. And Lombok is going to help you with all the annotations that are required, which make your life like 10 times easier. You just go type LOMBOK, and yeah, so I have installed it. So if you haven't, then you can install Lombok, and then you can play with all of these annotations for your project. Okay, so this is our email request, the way we send it to the server. Now we need a response. So for that, let's create another payload. So new Java class email response. So this is the response we get from the server after we send our request. So this will consist of some variables such as success, whether the email was sent successfully or not, the job ID of the job group, and the message we get back from the email response. So let's create this now. So first we have our fields. So we'll be having private boolean success. Next is private string job ID. Private, oh sorry, make sure you spell it right. And make sure you spell it right again. You have job group. So each quad's job is uniquely identified with job ID and job group. So you need both of them to have a unique job. There can be multiple job IDs inside one single job group. So we'll talk about that later when we come to it. Next comes in the private string message. We get back. Let's give it a nice name. And next we have the constructors for our email response. So email response boolean success and string message. Let's create the constructor. So this dot success equal to success, this dot message equal to message. So a simple constructor, nothing complicated. We'll see why we need the constructors later on when we create our API, but we need two types of constructors here. So let's create them. This one's going to have boolean success string job ID string job group and string message. This dot success again equal to success. Now as we write this out, we have to make sure that our variable names are rightly written. So make sure that you have the correct variable names and there is no spelling mistakes, and all of them is readable, pretty readable. Should not be something which is weird to read or to understand. So only by seeing the code, a person should be able to understand what's happening behind the scenes. Try to minimize the amount of comments you write. So make sure that the comments actually tell you why the code was written and not what the code is. So a comment like this here would not make sense, that this is a constructor. This is not a comment which is helping us understand anything about the code, right? So something which can be changed here is that we can write this constructor helps with so and so. So this is a way of actually writing good comments when you're creating a very big project, and also to make sure that if other people contribute to it, it is readable. So make sure that you write comments that explain the why behind the code and not the what. Okay, so last is the message. So this dot message is equal to message. Okay, great. So we now have all the fields ready, constructor ready, and this is going to be the response to our request that we send back to the server, and we get whether the email was successfully sent or the job was created successfully or not, the message we get back, and the constructors that are used for it. So the next thing is going to be the controller or the endpoints that handle or work with Postman or any other application that deals with API calls. So let's create our controller now. So let's go to a new package, call it web. The web is going to control the API endpoint. So let's create a Java class for that. It's going to be an email scheduler controller. Now this particular class will control all of our APIs. So it'll have the logic behind the APIs. And in this video, we'll talk about starting to implement our email scheduler controller, which handles the API endpoints for our application. So before we start implementing, we need to get in touch with two important concepts that we are going to use while we schedule our application. The first important concept is job detail, and the second is the trigger. So let's revise what they mean first. So a job detail represents an instance of a job. It also contains additional data in the form of a job data map that is passed to the job when it is executed. So the job data map or the job detail will include the email of the person to whom we are sending the email, the subject, the body, all of the information that we get from the email request. And the job data map will hold that for the particular job and will be passed to that job when it is executed. Now, every job detail is identified by a job key that consists of a name and a group. A name being the job ID, group being the job group which we have inside our email request. The name must be unique within a group. Now comes the trigger. So a trigger, as the name suggests, defines the schedule at which a given job will be executed. So the trigger basically tells Quartz when should the job be triggered. A job can have many triggers, but a trigger can only be associated with one job. So we need to read that again. So a job can have many triggers. So one job can have many triggers, but only one trigger can be associated to one job. Now every trigger is also defined by a trigger key, which comprises of a name and a group. The name must be unique within a group. Just like job details, the triggers can also send data to the job. Now these are the two very important components of Quartz that we'll be using to create our job detail and trigger for our API. We'll also be using the trigger builder and job builder, which is basically an API to construct these two above. So let's get started. Let's start creating our job detail. So we'll have a private. So I've left some space here to actually implement the API, but for now, for this video, we'll be implementing the job detail and the job trigger. So private job detail build job detail. So this is going to be our application which deals with making the job, and it is going to have the email request schedule email request as our arguments. And yeah, so let's import all the functions that we are supposed to, like classes. And yeah, so let's initialize it first. So job data map equal to new job So this is basically a map, a very typical map which Quartz uses, and we put on the information that we need to pass on to the job execution when we schedule it. So job data map dot put, and you can predict what we're going to do here. So we'll have the email is going to be schedule dot get email. Next, so the same thing again, and we do it for the subject and the body. So we have the subject, and this again becomes get subject. Great. And the next thing is for the body. Sorry about that. This becomes body, and this becomes get body. Great. So now we have the job data map, which is going to pass the information to the job and schedule the email using the email subject and body, which the job data map has. Now let's build our job detail using the job builder API. So return job builder dot a new job, and now will be dot with identity, and the identity is going to be UUID dot random UID dot to string, so a random name, a unique number name, random name, and the group is going to be email jobs. Now the next thing which we need to have is with description, and the description is going to be send an email job. The next part is using the job data map, so using job data, and the job data is going to be job data map. So this is the information that will be passed to the job. Next is going to be store durably. So this basically tells Quartz to store the jobs even without a trigger and persist them in the database. And the final comes with the build. So the build takes care of building the job. Now the new job takes in a parameter, and that parameter is basically the class in which the job is implemented. So the class which handles scheduling of the email, the meat of our Quartz application, that will be passed out here. So let me just create it right now. So email job dot class. Now we haven't created email job yet, so let's go ahead and create it now. So we'll create a new package first, and it'll be a Quartz dot job, and inside this we have our email job class. So let's go back ahead here and let's import this so that we don't have any errors for now. And great, so this has to implement a job, so let's make sure it does that. Let's go here and we should do implements Quartz job B, and when we implement the Quartz theme we need to have a function here. So let me just write that for now. So we override protected void execute internal, and this is going to have the job execution context here. So it does not implement it, extends it, my bad. And yeah, so this is going to be the meat of our application, and we'll be implement this in some time. But for now, let's go back to our email scheduler controller, and this is the implementation for building a job detail. Next comes implementing the job trigger. So let's go ahead and work with that now. So here we do a private trigger build trigger, and this takes in the job detail, and it also takes in the zoned date time, or basically when do we actually start scheduling the email or start the trigger. And let's import this from Quartz. And now we can start implementing it. So we'll just go right ahead and build our trigger. So we'll do a trigger builder dot new trigger dot for job, and it's going to be the job detail dot with identity, and the identity is going to be job detail dot get key dot get name of our job, and the group is going to be email triggers. The next part is the description. So with description, so we send email trigger, and we start at, and we do a date dot from, and start at dot to instant. This is going to be the start time for our trigger, when should the trigger actually be triggered. And with dot with schedule, and we'll do a simple scheduler builder dot a simple schedule, which basically does with misfire handling fire now. So we'll come back to this and what this actually means and what is actually happening here. But for now, this is how we are going to schedule it. And whenever there's a mishandle, it'll just show us the misfire handling instructions and fire it again. All you have to do is dot build. And this is basically how we implement our trigger. So the trigger has the for job, which includes the job details which you're using. Identity is the unique name and group. Description, start at the point where it should start. And the schedule is basically a simple schedule which fires it with a misfire handling instruction and builds it using the trigger builder API. Now we have a job detail and job trigger. The next part is to implement the post API, which takes in the email request and then schedules our job. So in the next half of this playlist, we'll finish up building the email scheduler controller. We'll finish up building the email job, which handles the main heart of the Quartz application that we're building. And we'll also test our application using Postman and see it working live in action. So in this video, we'll finish up building our email scheduler controller so that we have ready to use endpoint, a post endpoint, which we can use to schedule our emails. In the upcoming videos, we'll also create a get endpoint from which we can see all the emails that we have scheduled, and also look at how the database looks behind the scenes after we put in some information from Quartz. Okay, so let's continue building, or actually finishing building our email scheduler. We need a bit of annotations here, so we need a logging annotation so that we can log some of our messages. We need a REST controller to make sure we have REST controlling mechanisms on our application. Now we need the scheduler that we are going to use, so let's do an auto wire of a private scheduler. Awesome. Now we can use the scheduler to schedule our jobs and make sure that all of them run when we want them to run. Let's go ahead and start creating our post mapping. So let's have a post mapping annotation. This is going to be the sort schedule email. So you can have multiple things here. So you can have schedule email, schedule a job, anything which you would like. For the simplicity of this tutorial, we'll be going with schedule/email. The next comes in the method declaration. So it's going to be a response entity that will be sending back, and it will have the body of an email response and the function name. Now let's have some parameters here. So it will be a valid request body, which is going to be an email request. Okay, so this is our method declaration, where we actually implement our schedule email for the Quartz application. Now let's go ahead and start implementing it. So let's wrap the entire method inside a try catch block where we are able to catch any of the exceptions. So mostly we'll be having a scheduler exception from Quartz which we need to handle. So we can do a scheduler exception se and just do a log.error here, error while scheduling email, and also give out this so that we are good to go. Now once we give this out, we need to make sure that we also give out a response, an email response back to the user who's using it. So what we can do is we can create a new email response object. And if you remember how this looks like, let's actually go and see this. So we have a constructor where we have the success and message. We also have another constructor where we have the success job ID, job group, and message. So which one do you think should we use here? So here we'll be using the first one where we just do a success as false, and the message is going to be error while scheduling email. Please try again later. Can be as descriptive as you want it to be, so that's up to you. And let's have it down so that we can see it. And all we do is we return this back. So return response entity dot status. There's going to be a HTTP status of internal server error. So let's find that, because it was an issue by because of Quartz. Dot body is going to be an email response. Awesome. So now we have we are able to successfully catch our application which our method might throw, and the next part is to implement the post structure for our method. So first, let's actually get the zone date time using this date time, the zone ID and the date which we take from the email request. So if you go to email request here, you can see that we're asking for the date time and the time zone. So now we need to configure that into some property which Quartz understands, which is going to be zoned date time. Let's call it date time only. It's going to be zoned date time dot of email request dot get date time, comma email request dot get time zone. Awesome. So now we have our date time. Next, let's do a quick conditional to make sure that the date time dot is before zone date time dot now. So if it is scheduled in the past, then we cannot actually send it to the user. We can't schedule it, right? So if we are scheduling it in the past, then we have to tell the user that the date must be after the current time. So let's just do an email response there. So let's do an email response equal to new email response. And since it's a failure message, it's going to be false, and the message is going to be date time must be after current time. Great. Let's get this down so that we have enough space to see it inside our single window. Great. Okay, and now we can just return this back. So I'll just copy this return method and paste it here. Okay, now comes the part where we actually deal with the Quartz part. So first let's build our job detail. So we do a job detail is equal to build job detail, and we pass it in the email request. So this is what we had built in our previous video, where we pass in the email request, we create a job data map, and then we build a job using the job data map, which has the email, subject, and body. So now that we have finished implementing that, we can use it to get a job detail back. Next is going to be a trigger. Trigger is going to be equal to build trigger email request, and now we have our job detail and the trigger ready. So okay, so here I think we made some changes, so it's going to be the job detail and the zone date time. My bad. So this is going to be job detail comma date time. Great. So now we have the job detail and the trigger ready. So the next part which we need to work on is scheduling the job. So this is how simple it is to actually schedule a job using Quartz. So we use the scheduler dot schedule job, and all you have to do is pass in job detail and the trigger, and voila, that's how we schedule a job using Quartz. So it is that easy to use the framework because it gives you out of the box functions to use and schedule jobs. And of course, if you would like to see how it works behind the scenes, you can click on the scheduler Java and see how it works behind the scenes, which I really highly recommend to do so. The next part is about sending back the response to the user. So in this particular case, we were actually able to schedule a job, right? So we should be able to send back a positive or a true success email response object. So let's create that. Email response is going to be new email response, and the success message is true. And let's send back the job detail dot get key dot get name, and also the group. So job detail dot get key dot get group, and let's send a message with this, which is going to be email scheduled successfully. Great. And now that we have this ready, let's send back a response entity. Okay, email response. So this is how we implement a post request for our Quartz scheduler, where we are able to schedule an email. So let's really quickly go through what we have built here and make sure that we haven't missed out anything here. So first, we make sure that our controller has all the required annotations. So since it is a controller, it has a REST control annotation. We'll be using our logging functionality to make sure that we catch the errors while we are in development. So we have the SFL4J annotation. Next comes in the auto-wired scheduler, which we'll be using, which is given by Quartz. And we use that to create our post mapping. But before we do that, we have two helper functions, which is the build job detail and build trigger, which help us build the job detail using the job data map, and also the trigger using the trigger builder to make sure that our jobs are scheduled at the right date time and with the correct job information. Next comes in the schedule email method. So here we first convert our date time and the time zone into a zone date time, which is a standardized form to make sure that we have the date time from any time zone across the world. We then check if the time, if the scheduling time is before the current time. If so, then we return back an internal server error, or actually we do a bad request here, because this is something which the user did incorrectly. So we have to tell them that it's a bad request to send, and we send a message that the date time must be after current time. Now, if the user has passed through this, or in other words, if the date time is after the current time, then we move on to building the job detail, building the trigger, and then scheduling the job using the schedule job method. Next, after we do this, we then create a new email response object with a true success boolean, the name and the group of the job, and the email scheduled successfully message, and send that back to the user using an OK status, which is the 200 status code. So this is how we create a post mapping, and our email scheduler is completely implemented.
In this video, we'll start implementing the last part of our application which is implementing the job. So let me show it to you right now. So we have a email job which we need to fill up. So basically we need to tell the application what happens when a Quartz job gets triggered. So when it gets triggered, it goes inside the execute internal method, and this gets invoked whenever the time comes to it. And then we use the job execution context to handle the things that happen around the Quartz application and the job. So now, first, we haven't actually run our application yet. So it's been 6 videos and we haven't even run it once. So let's first do that right now and make sure that the application is running. So for that, let's actually write a very simple get mapping. We'll just throw out a string saying that this is a get method, and we'll just run that on the browser to see whether our get API is working or not, so that we can make sure that our application is up and running. So let's do that quickly. We are get mapping. This has let's say a get, just a get should be enough, and public response entity of string. So we have a response entity which is going to be a string, and this is basically going to be a get API test. And let's implement this. So all we need to do is basically return response entity dot okay, and the body is going to be get API test pass. And yeah, have this. We are getting an error here, so let's just see what the error is. Yeah, no errors, all good to go. So this is basically our get API which you're going to use to print out get API test pass and make sure that our application is up and running. So before we run our application, make sure that your data source URL and your data source stuff is filled up. This we'll fill it up later, this part. We'll do it once we start implementing our sending email logic using mail properties and Java mail sender. So for now, we just need to run the application. So have your data source filled up. Let's actually go and run it now. So you can just go here and use this handy function. Okay, so before we do this, make sure that the SQL server is up and running. So let me just do it right now. Brew services start MySQL, so that when we run our application, we automatically connect to our MySQL database. Let's check that here, and so we used to set it up here as well. So let's do a refresh, and yeah, so we have our Quartz demo up and running. Now we can go ahead and start running our application. So let's get this to the side, close this, go inside QuadStudio and hit run. Now once we make sure that the application is up and running, the next thing to do is to actually start implementing our email job. And in this video, we'll implement the part regarding the job execution context, where we need to understand how that works. And the next video, we'll actually implement the send email logic. So that is the amount of stuff we're going to do for this video. So let's wait for our application to run. So we have our Hibernate ORM running, JPA is running, we have our Quartz scheduler running locally with 5 threads, and yeah, we have our application running on port 8080. Let's quickly check this out. So 8080, we do a get, and as you can see, we get a get API test pass. That means our API, our REST application is working perfectly. Let's go ahead and close this now, and now we can start implementing our email job method. So if you remember, when we go to the controller, we are filling out some details inside a job data map. So all of the data which we fill out here, this we use it when we actually get inside the execute internal method, and we get that job data map back using the job execution context. So let's see what I mean by that. So now we do a
job data map, job data map, job execution context, get merge job data map, and that is how we get back our job data map. And now basically what we do is fill up our boilerplate. So we need to extract some things here. So we need to extract a subject, which is going to be job data map dot get string, and this is going to be subject. So what we're doing here is that the job data map dot put, which we put here, we're just taking that back out in the execute internal method, and we do the same thing for the body. So we just do this as a body, and this is going to be body. And the last thing is the recipient's email. The recipient email. I'm not sure if I spelled that right, but let's just assume that I did. And oh my bad, did not have to run this. And this is going to be email. Yeah, so let me just check that real quick here. So we have email, subject, body, all good. And now that we have the information regarding this, what we need to do is send that information to our send email logic. So we can do a send mail, and this is going to have a lot of stuff. So let's implement it here. So private void send mail. So this is going to have a from email. So it's going to have a string from email, string to email, string subject, and string body. And make sure to spell everything right. So this is basically what we have for our application. And now we need to implement send email. So before we do that, in the next video, in this video we talked about setting up our REST application. So we had our data source ready, we had our MySQL server ready, and then we used all of that to run our application and then see out the get API. Then we talked about email job. So here what we did was we talked about the execute internal method. So this method is invoked when the Quartz job is triggered. So if suppose we schedule an email to be sent at 12 a.m. in the morning, then at 12 a.m. this method starts getting invoked, and then you get the job data map, you get the subject, body, recipient email, and send that to the send email function. In this video we'll talk about implementing our send mail logic, which is the crux of our application, which we use to send an email to the recipient. And let's just get into it directly. And once we finish implementing this, we'll just talk about running the application again. And in the next video, we'll start testing our application using Postman. So cross out the update notifications and let's get into it. So first, let's add some annotation. So we want this to be a component bean. So we add the component method here, and now we need two beans. So first is an auto wired private Java mail sender. So this basically helps us send the mails. And another thing which we need is a private mail properties. Okay, using these two, now we can implement our send mail functionality. So send mail, first what we need to do is get the username. So what we do is a mail properties dot get username. Next is the recipient email or the to email. Comes after that the subject and the body. Now let's start writing our send email logic. So let's wrap all of this around a try catch. So a try and a catch. So let's first write a MIME message. This is going to be a message, and we create that. So mail sender dot create MIME message. Next, we use a message helper from MIME. So my message helper, and this is going to be equal to a new my message helper, which is going to have the message, the standard car sets. It's going to be UTF-8. This is just boilerplate code that I'm writing for sending an email, so just make sure you have that in it. So to string. Now that we have a message helper, we can add additional information to it. So we can do a set subject and then add that. We can have a message helper for setting up text, and that is going to be the body and in HTML. Let's check what the issues are here. So yeah, we need to catch something, so we'll do that right now. We need to catch what? We need to catch messaging exception. So we do a messaging exception here, and let's log the error. So all you have to do is system.out.println the exception. And now let's head back to this. So we need to do a message helper dot set from. It's going to be the from email, and the final part is the to. So message helper dot set to. It's going to be to email. And now the last thing which we need to do is mail sender dot send message, and this is how we implement our send mail logic. So let's go through what we did here. We did a couple of things. So we used the mail sender bean to send our email over the email protocol that we have, and we use mail properties to add the metadata for our email. So we added helpers using my message helper, where we added subject, text, from, to, all this metadata, and then we send our message using the mail sender. And this is basically how we implement a send email application. So let's go through everything again from the beginning and see the flow of our application, because since this is a very a relatively complicated tutorial than what I had posted before, we need to make sure that we did not miss out on anything. So first, the properties. We have our Spring data source. We have the Quartz properties here. We are using JDBC. We have our mail properties. This is going to be blurred out, so I will not be adding the password here. And we have our simple mail authorization stuff. Next comes the scheduler controller. So here we have a post method which schedules an email, takes an email request. So let's see our email request. The email request has the email, the subject, body, date, time, etc. Then the response has the success, boolean, job ID, job group, message, all of that. Then when the time comes, the email job is triggered, gets the job data map, and then sends the email using mail sender and mail properties. So let's get started. So before we jump into that, we'll just go through the implementation real quick, and what have we done before and where we are right now from video 1 to video 9. It's been a long journey. So let's go through all the classes real quick right here, and once we're done with that, we can then move on to testing the application. So here we have our application or properties, which basically has your data source, your MySQL stuff, and also your mail properties, your email ID, your password, etc., etc. Next is your email request, which basically is the payload or the info data that your client inputs and sends as a body in a post request, who gets a response back in terms of an email response body. And yeah, so one thing which we want to talk about here is that this was not there before, and make sure to add this in your code, and the setter and getter as well. So this basically makes sure that all the
non-null values are also included inside the JSON when it gives an output, and the setters and getters are basically, well, setters and getters for the class. Next comes in the email job, which basically is the heart of our application. It uses mail sender and mail properties to then create the message and then send it. And we also handle job execution context and the job data map in this set of lines of code, and make sure that the appropriate email is sent to the appropriate person. And finally, we have our controller. So if you go inside web, we have a controller which handles everything for us. So it handles scheduling of emails, it handles building the job detail, the job trigger, and also scheduling the job for us, and does some basic validations. Uses these helper functions here, build job detail and build trigger, to make sure that we are up to date with our stuff. Okay, so let's test it now. So let's run it first, and we'll be using Postman to test the application. It's an API client, so make sure that you have Postman installed inside your laptop or a computer, or if not, then any other API client works. So we have our application up and running. Let's open Postman. And so first what we're going to do is we are going to do a get request on /get. If you can see here, we had made a simple get mapping just to make sure that the API is working. So my bad. Go to Postman, get this up and do a send, do a get request, and we'll just make sure that we get back the pass. So our REST API is working, and now let's do it. Let's do a post and schedule an actual email. So here I'm scheduling the email to myself, and the subject is one lead coder day keeps unemployment away. Pretty important stuff. And the body is that you either reverse a linked list or you just get out. And date time is in this format, so it's the date and then T, then hours, minutes, seconds, and the time zone is Asia, Kolkata. And yeah. So first, before we actually do a successful post, let's actually mess with it a little. So what if I put this as 06 and this as 29? So this is basically before time. So this should give us an error. So as you can see, we have our error message that the date time must be after current time. So our validations are working pretty fine. And all I have to do now is make it as 07 and send our request. And we get back the output as true. This is the job ID, job group, which we had used to schedule the email, and that's it. That's how we actually run our application, and we have scheduled an email to be sent to me next month this time. So now, if you are still not convinced of whether the email was sent or not, what you can do is use a debug mode inside Quad. So let's actually do that right now. So let's stop the application and run it again using debug mode, and then you can see every single state happening step by step. You can see what your variables are, what's happening behind the scenes, etc, etc. So let's actually do that right now and see how a debugger is used inside IntelliJ. So let's say I want to keep track of everything that happens. So I want to keep track of which request is coming in and where is it going out, all of that. So what I can do is I can create breakpoints. So if you click on a line here, it will stop the execution of the program for that line. So let's say I do it here. So everything before this, all the variables, I can see them inside the debug console, and we'll see that in a minute. So I want to stop it here and see what is inside my email request. I want to see what's inside date time. That way I can see it here. And then I want to see the response, right? So I want to put a breakpoint here and see the email response that I get back. Now what you have to do is run it using the debug mode, and this takes up comparatively a bit more time to start when you compare it to the run button, because it IntelliJ does something behind the scene for it to make sure that the breakpoints are being actually hit. Now once this is done, should be over anytime now. And yep, now what we have to do is go to Postman and do a send here, basically trigger our process. And once we do that, you'll see that we go inside the debugger console. So give it a minute, and yep, so now we are inside the debugger console, and here we can see all the variables before line 40. So this is the current object of the email controller. We have our email request. So this is what we had sent using Postman was this. We can see exactly how we want to see. We can see the date, we can see the time zone, Asia, Kolkata, rules, all of that stuff. Very, very interesting, very nice stuff to see. We can see our date time and also the scheduler which we had, declared here. And let's do a resume program, and then we get the email response. So now we have an email response and we can see what is happening behind the scenes in the email response. So yeah, pretty cool stuff, a pretty interesting way of seeing how the program works behind the scenes. And now you can actually move around and see how each and every state changes when it goes through the program. You can see the scheduler, you can see what's happening behind the scenes inside the scheduler as well. You can see the job factory, you can see the job data map, you can see the log errors, job manager, all sorts of good stuff. And yeah, so that was it for this video. We tested our application, we made sure that it is working, and we also saw how it is working behind the scenes using debugger. And now the final part is basically exploring Quartz a bit deeper and seeing what other options we have with Quartz and what the kind of power it provides us. So that is what this video is going to be about. We'll be going deep inside the Quartz database and seeing what has happened behind the scenes when we actually, go through the line 43, which is schedule a job. So as you can see, we did not write any SQL code, any Hibernate code, we didn't do anything other than, making those tables for Quartz in the beginning. That's all we did. All we did was run a SQL file, which you could get off the internet for Quartz. And then all the tables for us were created, all the constraints, the foreign keys, primary keys, all of that was handmade for us. And Quartz was handling that behind the scenes where we were running our API, basically this particular line of code. So let's see what's happening behind the scenes and what actually, our database, how our database looks like. So go here, and these are all the tables that we have. So we have everything here given by Quartz. So we have the blob triggers, calendars, cron, etc., etc. So to be honest, I haven't used most of it. So I haven't used Quartz logs. I have never come across a situation where I had to see what is inside them, or it was always empty. Paused is when you basically pause your scheduling. So there is an option in a scheduler where you can actually pause and resume jobs. So if you have a job which is pending to be run or triggered, then you can just pause it, and then whenever you want, you can then resume the job as well. So this is what the pause trigger groups is for, where you can just see which jobs were paused. Fire trigger is basically which job was triggered and has already run at least once. Job details gives you all the information about the jobs. So let's actually see it in action now. So yeah, we are inside a console for this, and let's just do a select star from job details and see what we get back here. So if you can see on the console, we get an output. So I've actually scheduled a bunch of jobs, so ignore that part, and let's just see what is happening here. What are the columns? So we have the scheduler name, which is the Quartz scheduler. We have the job name, which is basically a unique ID. The group is email jobs, which we had hard coded inside it. Description was also hard coded. The class is the job from which it will run. So it's the email job. The crux of our is durable is basically whether it's in the database or not. It is not concurrent. We haven't updated the data yet. There hasn't been any request recovery, and the job data is basically enigmatic. So there's the way of seeing that, but we know what the job data looks like. So this is basically what we see inside Quartz job details. And now let's actually see it for other tables as well. So if we do a select star from Quartz, and if I want to see all the triggers, so let's see all the triggers that we have inside our application. So we have 3 triggers right now. Again, scheduler name, trigger group, email triggers, the job name. Previous fire time, has it been fired before? -1 means no. The state of the trigger, so all the triggers are waiting. The priority is top, which is automatically given by Quartz by its own priority algorithm. We can change that, but we haven't yet. The name of the calendar, so if you're using a Gregorian calendar or something else, then it shows up here. The job data, which we give via the trigger, and the misfire instruction, basically what to do when there's a misfire. So these are all the columns we have for Quartz triggers. Similarly, you can see it for
other bunch of stuff. So blob triggers, calendars, fired, log, etc., etc. So some of them are mostly empty. So let's find out which ones. As you can see, this one is basically empty because we haven't. There are no multiple instances for our quad scheduler, so that we can handle them. So if you're working on a microservice, then you will have this handy. If you have multiple instances running for quads at the same time, then you can check in the interval what was happening, which scheduler has a last check-in time, etc., etc. So this is what happens behind the scenes in the databases. And if you would want to learn more about it, then you can go inside the description below and then see how much deeper you can go with quad schedulers and the databases. So this is how we implemented Quad's application, which can be used to schedule email. And we did not write a single SQL command. We just ran a SQL script, and it did all the work for us. And using this one line of code, which is scheduler.schedule job, we are able to populate multiple tables. We're able to schedule jobs and triggers. So this is how we actually saw how powerful Quartz is when it comes to scheduling jobs. So thank you for watching, and I'll see you in the next playlist. Good night. In this video, we'll learn how we can do single sign-on with GitHub authentication. Basically, we will be authenticating our Spring Boot application using GitHub, and we will be using the credentials that we use for GitHub to log into our application. So this tutorial is between intermediate and advanced. So to understand this tutorial and follow it smoothly, you will need to know the basics of Java, basics of how Spring Boot works, and also a bit about authentication. But we will cover that part in the upcoming series. So authentication should be covered, but you should know how Java and Spring Boot works, at least the basics of how you can build up REST API applications. If you would like to know more about how to learn Spring Boot and Java, there are multiple tutorials on the channel Programming Knowledge, using which you can learn how to create REST APIs using Spring Boot. So let's get started. So in this video, we will be making a very simple hello world of OAuth 2, where we will be authenticating our app using single sign-on with GitHub. And this will be done quite easy by taking advantage of the auto configuration features in Spring Boot. And for this tutorial, we'll be following the official Spring guide, which tells us how we can have an OAuth 2 feature inside our application. So let's get started. Here in front of you, I have a very simple Spring Boot starter project. It has nothing, as you can see. It just has a POM XML, which has the basic data that we get when we create a Spring Boot project using Maven. Now let's start adding some stuff to our application. So first, let's quickly add all the dependencies that we need inside our Spring Boot application, so that when we start developing the application, we have all the libraries and the set of things which we need. We will go through all the dependencies that we have added inside the project, so that we know what we are working with. So let's quickly go ahead and do that. So first we have our parent. So the parent has to be the Spring Boot startup parent, which basically gives you all the Spring Boot capabilities and features that you need inside your application. And next comes in the dependencies for your project. So these dependencies help you quickly develop your application. So let's add them to the form.xml, and let's go through them one at a time. So here we have our properties, which basically are telling us to use 1.8 Java version, and the source encoding should be UTF-8. The dependencies here are Spring Boot Starter OAuth 2 client, which gives us a lot of out-of-the-box features which we can use to configure our OAuth 2 client. Next is the Spring Boot Starter Web, which helps you write REST APIs using Spring Boot. We have a couple of dependencies here, which has jQuery, Bootstrap, and WebJAWS. These will help us with the HTML pages that we have in our application, and help us understand how we can have a good looking bootstrapped application with JavaScript capabilities inside our application. And last but not the least, we have our Spring Boot Starter tests. So we will be writing some tests in the upcoming videos, where we'll be testing how our application works and to make sure that they're working fine.
And finally, we have our build plugin, which basically tells Spring Boot to use Maven and to quickly load these dependencies every single time. So now that we have our pom.xml ready for the application, let's get started and create our application runner. So to do that, let's create a package called as pom.example, and let's have a new Java class called as OAuth runner. This OAuth runner basically will run our application. So this is going to be Spring application dot Spring application. This is going to be Spring application dot run. Spring application dot run. And let's call this our Spring Boot application. And this is going to be inside a main method. So public static void main string args. Now inside this we can have our Spring application runner dot run, and this will have the OAuth runner dot class and the args that we usually provide. So now we have a very basic Spring Boot application ready. Before we actually jump and start with our application, let's quickly configure the run configurations here. So to do that, in IntelliJ, I'm using IntelliJ IDE for Java development. So I would highly recommend using this. And if you are a student, then you can also get a student license for free. So make sure that you use that for your benefits for development. So let's add a configuration here. So go to add configuration. Let's quickly make it big. Go to plus application. Let's name it as OAuth runner. Local machine. The main class is going to be OAuth runner, and this is all we need for now. Apply. Okay. So we have a Spring Boot runner, OAuth runner, which we are ready to go when we want to run our application. Now let's get started and let's quickly build our application. So first, what we need to do is create an HTML page which shows us what our application looks like. So to do that, go to resources, new directory called as static, and let's create a new file called as index.html. Now let's quickly add some code to our HTML file. So here we have a very simple HTML page which has some scripts. So this is where we use the dependencies for jQuery, Bootstrap, and have some styling to our application. We have a demo title, so let's change that to Spring Boot OAuth application. And make that here as well. Now this HTML page will be used to run our application, and this is what we see when we refresh our page, authenticate GitHub, and then come back to our application. We will see the heading as Spring Boot OAuth application. And let's actually write that as using GitHub. Now this is the part where we are almost 90% done with the Spring Boot side of development. So this is all we need to create a Spring Boot project from the development point of view. But now we need to set up the GitHub client authentication and configuration, where we use the GitHub client secret and client ID to help configure our application. So before we do that, let's quickly have our application.yaml ready. So this is how it's going to look like. So inside resources, what you need to do is you need to have a file called as application.yaml, and this file will contain everything that you want. So this is the Spring Boot security or to client registration with GitHub, and these are my secret client IDs. So don't worry, these will be deleted when the video is created. So until then, this is what I have, and let's see how we get these from GitHub. So this actually helps us and contact GitHub and use GitHub as a resource server to authenticate us inside it. So let's see how we do that. Now to do that, what we need to do is first log into GitHub. Go inside github.com. Then quickly go inside settings / developers, new OAuth app. Here give the application name something. So we'll be doing a tutorial Spring Boot OAuth GitHub. The homepage URL is going to be localhost 8080 because that is where we'll be having our application run. You can add a description, but it's normal, and the callback URL has to be this. So the OAuth redirect URI is the path in the application that the end user's user agent is redirected back to after they have authenticated with GitHub and have granted access to the application on the authorized application page. So this is the callback URL, and you can read more about the callback URL here in documentation. And this is what we need for our application to be registered, and then you can do a register application. Great. So now we have created an application successfully, and now the two things which you need is the client ID, which you can see here, and a client secret. So you can just do a generate new client secret, and it will generate another unique client secret for you. Make sure to copy it because you won't be able to see it again. And once you're done with that, you can start using your application. Now that we have our GitHub authentication done, we need to update your application YAML with these configurations, and you are good to go with your application. So now, before we actually see this in action, let's just talk about what just happened and what we just did. So the app we just wrote in OAuth 2 terms is a client application, and it uses authorization code grant to obtain an access token from GitHub, which is the authorization server. It then uses the access token to ask GitHub for some personal details, including your login ID and your name. In this phase, GitHub is acting as a resource server. It is decoding the token that you send and checking if it gives the app permission to access the user's details. If that process is successful, if you're actually able to authorize using GitHub, the app inserts the user details into the Spring security context that you are using to authenticate. Now, if you look into the browser tools and inspect elements and follow the network traffic for all the hops that we make, you will see the redirects back and forth with GitHub, and finally you will land back to the home page with a new set cookie header. This cookie, also called as JSessionID by default, is a token for authentication details for Spring or any servlet-based applications. So now we have a secure application in the sense that you can see content a user has to authenticate with an external provider, GitHub here. We would normally not use this for a banking website where security is the top priority, but for a basic identification purposes and to segregate content between different users on your site, it is an excellent starting point. That's why this kind of authentication is very popular these days, where you see that you can log into an application, log into Facebook, log into Gmail using different GitHub, using GitLab, etc. etc. Now let's run the application and see the application in action. So let's click on run. Now when we are running our application and testing it, the cookies and the history has to be cleared. So I would recommend that you always use an incognito window to check or test your application so that you can always authenticate GitHub and see that page happening. So here we have Spring Boot getting fired up. Everything is good so far. So OAuth runner has been started on port 8080, and the Tomcat web server is also ready. Now let's see what we have implemented. So as I said, open an incognito window because it will not have any cache, any cookies that you have left. Open 8080, and once you open 8080, it will immediately go and as you can see, go to github.com and
ask for your authentication to sign into the Spring OAuth 2 app. And once you sign in, once you give it your credentials, you will be coming back to the Spring Boot OAuth application using GitHub. So this is how we create a very simple Hello World application which uses Spring Boot and OAuth 2. In the upcoming videos, we'll add a welcome page, we'll add a bunch of features to our application to make it a complete application, and also understand how Spring Boot OAuth works in a much better sense. So thank you for watching, and I'll see you in the next video. In the first video, we had set up a very basic simple authentication runner which basically redirected the user to the GitHub authentication page once they spin up their local host. Let's see what we had built in the previous video, and then we can move on with what we are going to build next. So here I have a very basic OAuth runner. We have an index which we had used in the previous video, where we have our OAuth application running. We have a container, and we also have the runner Spring Boot, and we also have the application.yaml which has the client secret and the client ID from GitHub. So if you haven't seen the previous video, I would really highly recommend you to see the first video. The link is also in the description below. Now that we have our authentication running, always make sure that you're running your Spring Boot application or your local host on an incognito web page so that there's no cookie and you are not automatically logged into GitHub. So just make sure that you're always running it in a incognito window. So let's have a new private window for us. And here we'll start running our application. So we have localhost 8080. And as we open that, we are automatically redirected to GitHub here. And then you can put in your information, hit sign in. And once you are authenticated, you will be sent back to the local host and you will be displayed as Spring Boot OAuth application. So this is what we had built in our previous video where we had a simple application. And now in this video, we'll start adding features to this particular web application that we have. So now that you see, we only are redirected once we just log in or spin up the application. How about we give user a choice or a conditional choice where they can then decide if they want to log in via GitHub or not, and then show them the name back. So for example, my name is Ronak, and if I want to log into GitHub, I just have a button which says click here to log into GitHub. When I log in, it shows me that I have been logged in as Ronak Vyas with my GitHub user information. So let's start adding features into our application so that we can build that. So how are we going to do this? So in this video, we'll modify the simple application that we have, and we'll do that by adding an explicit link to log in with GitHub. Instead of being redirected immediately, the new link will be visible on the homepage. The user can choose to log in or stay unauthenticated. So they have two options. Only when the user has clicked on the link with the secure content be rendered. So this is called as conditional content, and we'll be doing that on the homepage, which is the index.html. Now, to render content on the condition that the user is authenticated, you have the option of doing it at the server side using Spring Boot and Java, or on the client side using jQuery. In this video, we'll be doing it in jQuery, but you can easily refactor the code for any of your JavaScript libraries such as React or Angular. So let's start and let's see how we can build this. So we have our application here, we have the login. So let's change this to video 2. So all we can do is have a login page which gives you the choice to log in or not using GitHub, and we'll say conditional. Yep, great. And now we can add our stuff here. So let's have a body. So we have the body ready. Now we have the container, and let's have two divs now. So first div is going to be unauthenticated, and this one will have via GitHub. So GitHub, and here we have an A tag which links to the URL which we use inside GitHub, which is going to be /OAuth2/authorization/ GitHub, not GitHub, GitHub. So whenever the user clicks this particular button, so click here, they will be redirected to the /auth/authorization/GitHub URL, and this is basically where we then hit the GitHub server and we start the authorization process. So now let's see how we can demonstrate conditional content. So this is a one div which we have. So let's make sure that everything inside body is indentated. Let's have another div. And here we'll be having another class. So let's have a class container. This is going to be authenticated, and using these two sets of classes we'll be showing the content. And let's first not display it, so we'll do display none, so it is hidden first and we will not be able to see this. And this will basically say logged in as, and this is going to be a span, and this is going to be having an ID of user. So we have ID, it's going to be user. So this is currently empty, but we'll be using jQuery to actually fill this particular span. So let's start writing the script for that. So everything jQuery goes inside script, inside HTML. Make sure that the script is of type text/JavaScript. So that is what we are implementing right now. And let's write some very simple jQuery which just fetches everything that we want, the data of the basically the name of the person who has been authenticated using GitHub, and then we can move ahead from there. So we have $get, and let's say we have /user, which is basically how we get our info back. We'll be implementing the /user endpoint in a minute. And then we have a function. The function is going to have data in it, so we'll be using the data. And now let's start implementing things inside here. So inside data we are going to have, we'll be using jQuery again, and what we tell jQuery is that whenever you find the ID user, take the .html and add data.name inside that. That is something, that is the first thing which we do, that we make sure that we fill the span with the name which we get back from GitHub. The next thing what we do is we take up unauthenticated. So what we tell jQuery is that take the class unauthenticated and hide it. So this div is hidden once we log in, once we get data back from GitHub. And the next thing what we do is the same thing, but we show authentication. So dot authenticated, and all we have to do is dot show. So we don't need semicolons here, we can work without them as well. And this is basically how we have conditional content on our HTML page using client-side jQuery. So what is happening here? Let's go step by step again. We have two divs. One div is unauthenticated, the other one is authenticated. The authenticated div is initially displayed as none, so we don't see this initially, we just see login via GitHub. Click here. Once we click here and we are redirected back to our local application, we get a data back from GitHub using the endpoint /user. We will be implementing this in a minute. Once we get the data back, we fill the span with the data name, we hide an authenticated div, and we show the div which is authenticated. So this is our client-side code which we will be using to make sure that we have everything set up ready from the client side. The next part is running the server-side code. So the /user endpoint. Now we'll be adding the server-side endpoint that we just mentioned, calling it /user. It will send back the currently logged in user, which we can quite easily do so in our main OAuth runner class. So let's see how we do that. So first we'll be adding a REST controller here. So if you're not familiar with REST controllers, please watch the REST API playlist from using Spring Boot in the Programming Knowledge channel, and the link will also be in the description below. We will call this a REST application. We will have a get mapping. The get mapping will be for, as you expected, /user, and this is going to be for another method that we have. It's going to be public return a map of string and object, and let's make sure that we have the map imported from util, and this is going to be called user. Now inside this we will be having a lot of things, so we'll talk about that in a minute. Let me just implement it first. So we have authentication principal, we have OAuth to user. Let's call it the principal. Yep. The next thing which we need to do is implement it. So we get the data in principal, and now we need to return back the name from the principal object. So we do return collections, not an empty map. We go with singleton map, and we have the name, the key as the name, and the value is going to be principal dot get attribute, and we get back the name. This is the endpoint which we call back. So let's talk about what's happening here. So here what we're doing is we make sure that whenever we hit the /user endpoint here, we get the OAuth user which we currently have at that time, so your GitHub user, and we get back the name of the user from that, and we put that in a map, and we then access the key of the map from the value. So we access the value calling data.name. So this is the name that we have, and we call data.name, and we get back the principal.get attribute. So this is how we get back our name from the OAuth user. And the last thing that we need to do here is make sure that our application or the home page is public. So this is the one final change that we need to make. The app will work fine now and authenticate as before, but it's still going to redirect before showing the page. To make the link visible, we also need to switch off the security on home page by extending web security configurer adapter. So let's say what we mean by that. So let's actually add that. First, we extend our application, extends web security configurer adapter. So we'll be extending this, and let's actually write our function. So we override protected void configure, and we have HTTP security. It's called HTTP. This throws exception. Let's implement it. So we don't have to implement it, we have it right here from the Spring docs which we are following. So let me just get it right from there, and we'll just talk about what it's doing. And let's import all the classes that we want to make sure that we have everything ready. Let's clean it up a bit just to make sure that everything looks good. Yep, looks about right. So let's talk about what's happening here. So Spring Boot attaches special meaning to a web security configurer adapter on the class annotated with Spring Boot application right here. It uses it to configure the security filter chain that carries the OAuth to authentication processor. Now the above configuration indicates a whitelist of permitted endpoints. So these endpoints are permitted and they will not be secure, and we can always access it. So how are we doing it? So we want to allow / since that the page you just made dynamic with some of its content visible to unauthenticated user. So as you see, this is unauthenticated and we want the user to see it. So we need to make sure that this is also permitted by the web security configurer adapter. Next is the /error, since that's a Spring Boot endpoint for displaying errors, and /webjars, since you'll want your JavaScript to run for all visitors, authenticated or not. Now you won't see anything about /user in this configuration, though everything including /user remains secure unless indicated by this particular request. So we only give slash the permit, we don't give /user the permit because that is where the authorization is happening. We just want to make sure that the unauthenticated user can see slash. Now finally, since we are interfacing with the backend over Ajax, we want to configure the endpoints to correspond with the 401 instead of that. We make sure that the authentication entry point is also unauthorized. With those changes in place, the application is complete. And when we run it and visit the homepage, we should see a very simple basic HTML which says login via GitHub. The link takes you not directly to GitHub, but to the local path that processes the authentication, which is /user. Once you're authenticated, you will be redirected back to the homepage where it displays the name. So let's run this and see how we have worked. Just to make sure that we are doing it correctly, we have extended web security, we have our /user endpoint, we have implemented everything that we need, and we should be good to go. So let's make sure that we are, and let's run this. We have the server up and it started running. Everything looks good. Let's open a private window, very important. No cookies, it'll be easy to see what's happening. Open 8080. And as you can see, the HTML is not perfect, but we can always update that. And we have via GitHub, click here. When we click here, we are redirected to this with our client ID, which I have in my application.yaml, which we had in the previous video. We give our inputs, we sign in, and when we sign in, we get back to our local application with our name. So logged in as non-affairs. So this is how you have a welcome page and a conditional content in your home page. In the next video, we'll add a logout button and we'll take it there, and we'll also start building up our fully authenticated OAuth application using Spring Boot and GitHub. If you have any questions, please add them into the comments, and thank you for watching. I'll see you in the next video. In this video, we'll add a logout button to our Spring application. In the previous two videos, we talked about how we can set up a very basic Spring authentication with GitHub, where we just spin our server up and we are directly redirected to the GitHub authentication page. In the second video, we talked about how we can have conditional logging, where the user first goes to the home page and then you can click on whether to log in or not. And once the user is logged in, we send back the username to back to our default localhost application and display that name. In this video, we'll add a logout button and see how that works. So there are a lot of steps built in here which we need to implement the logout functionality, because we are using a typical jQuery with our application and not using any front-end libraries. So we will need to add some level of code, but if you're using Angular or React, then these steps should be much simpler with the library. So let's get started. Now, the logout feature seems like a simple feature, but it requires a bit of care to implement. So it is worth spending some time discussing how exactly we want to do it. Most of the changes are to do with the fact that we are transforming the app from a read-only resource to a read-write one. So logging out requires a state change. So the same changes would be needed in any realistic application that wasn't just static content. So any content with any application where we want a state change, we will definitely need to do some kind of implementation for our logout functionality. So let's do the changes in the client side first. So on the client, we just need to provide a logout button and some JavaScript to call back to the server, ask for the authentication to be cancelled. First, in the authenticate section of the UI, we add the following button. So we add a div. First, let's always have a div ready so that everything is well in fragmented. We add a button. The button has an on click, and on click what it does logout, and the class is going to have some simple bootstrap classes. So let's have a class. We have button, we have button primary. So it's a very simple basic button and it says logout. So this is what we have, a very simple client-side changes that we have. The next thing that we need to do is have a script for logging out. So similar to this, we also have a var logout function, which basically does a post to slash logout, and it turns the span of user to nothing, a no string, an empty string. We then show an authenticated part where we want to click here to log in again, and we hide the authenticated part, which was this particular thing. So once we are logged out, we don't have to see the logout button anymore. So that is the jQuery that we have here, which helps us with this particular function. So the logout does a post to slash logout, which will do the right thing for us, which is basically clear the session and invalidate the cookie. To configure the endpoint, we simply need extend the existing configure method in our web security configure adapter implementation. So let's see how that works. So now all we need to do is have a logout method inside our application. So let's go to our authentication, and here what we do is just go up till here, and we can add this particular line of code. So this basically tells our application that whenever we reach slash logout, do a logout successful on slash, redirect the application back to the home page, and we permit this inside our application. So the slash logout endpoint requires us to post to it and to protect the user from cross-site request forgery, CSRF, pronounced as CSRF. It requires a token to be included in the request. The value of the token is linked to the current session, which is what provides the protection. So we need a way to get that data in our JavaScript app. Many JavaScript frameworks have built-in support for CSRF. In Angular, it's called as XRSF or XOF, but it is often implemented slightly differently than out-of-the-box behavior of Spring Security. For instance, the Angular implementation has to send a cookie called XRSF token, and if it sees that, it will send the value back as a header named XRFS token. We can implement the same behavior with a simple jQuery client, and then the server-side changes will work with the front-end implementation with a very few changes. To teach Spring Security about this, we need to add a filter that creates the cookie for us. So let's see how we can do that in the backend. So now, before we log out, we need to add a token, right? So let's do that first. We have added token here. So we do a .csrf, and we have C. And what we do with this? So we have C, and let's do a .csrf token repository, and inside that we have a cookie CSRF token repository. We do a with HTTP only false, and this will help us with the server-side implementation of our token. Next, what we need to do is add the CSRF token in the client, and for that we will need a JS cookie dependency. So let's first add our dependency. So go to dependencies, and the end before the test, all we need to do is add this particular dependency, which is WebJar's JS cookie version 2.1. We read the Maven project again. We make sure that it is working, everything looks good. We can connect to our application, sync it. And once we are able to build it and it is ready, we can then go back to our index and we can then start using it. So now inside script, what we need to do, we need to do an src, and we do that to slash webjars slash js cookie slash js.cookie.js. So we can now use a cookie inside our application. And now just where we are at the end, we need an Ajax setup where it basically tells our application that yeah, we need these things inside our application to create the cookie. So let's add that functionality inside our application, and then go through the setup once we are done with it. So this is the Ajax setup. So we have a before sign. So before we send anything, if the request is post, put, or delete, so make sure that we're doing a post, right? So when we have that, we then take up HTTPS. We send the token to the relative URL from settings.url. We create the header as XSRF token, and then we get that back. Then we clear the token from our application. So this is the Ajax setup that you need inside your application if you're using jQuery to make sure that your application runs and clears up the token so that it is secure. With these changes in place, we are ready to run the app and try out the new logout button. Start the app, load the home page in a new browser window, click on the login link to take you to GitHub, and then click on the logout app to cancel the current session and return the app to the unauthenticated state. Now, if you're curious, you should be able to see the cookies and the headers in the request that the browser exchanges with the local server. You can do that by hitting the inspect element functionality. Now, remember that now the logout endpoint is working with the browser client, and then all the other HTTP requests, put, post, delete, will also work just as well. So this should be a good platform for an application with some more realistic features which we add in the next video. So now that we have our setup ready, let's run the application and see what changes and what we can work with. So just to make sure that we have everything in place, we have the token repository which accepts HTTP only. We have logout successful. We have the dependency inside Spring, which we have the JS cookie. Inside index, we have the Ajax support, which makes sure that we get the cookie header and we clear it once we log out. And everything else looks good. So let's run it and see how it works. The server is up, and let's see if we are able to log in and log out successfully or not. And we also have a button. So let's see how that shows up and how it renders on the HTML page. It has started. Open a new private window. Let's do port 8080. So now we have our conditional page. We have via GitHub. So let's actually first log in to GitHub to see the logout page. We do this. We sign in. And now when we go back to our authorized application, we should see the logout page as well. Okay, so we have come back here. Let me see what's wrong in this place. Probably something to do with the HTML page. We can fix that right now. Let's go to IntelliJ. Let's completely refresh this. So we just need login, right? Yep, everything looks good. Let's see this again. So we have our div, we have divs ready, we have authenticated, unauthenticated, and everything else looks good. So yeah, let's refresh and see if we miss something out. The server is closed. Let's spin the server again. So we need to add the script before the local script. That is the mistake which we made. We have fixed that now, so it should definitely work. Adding the welcome page. Auth runner has started. Let's go to our page. Let's refresh. So we have login. Let's click. And since we already did redirect from GitHub before, we are logged in. We have a nice logout button. When we click logout, we come back to GitHub. So we can log in, goes to GitHub, checks it, we are logged in. When we click logout, we are logged out. And if you want to see how it works behind the scenes, we can do an inspect element to make sure that the network calls are also seen. This has to be responsive. Now let's go to network where we can see the network calls. So first we do a click, we go to GitHub, we come back from GitHub, come back to localhost. When we do logout, we log out and everything else goes away. So this is what happens behind the scenes, and we are officially logged out. Again, when you click here, we go to GitHub, we get the code from GitHub, and we are authenticated. We do a logout, and we get back from GitHub. So this is how we implement the logout functionality with OAuth 2. If it's not clear, please put in your doubts in the comment below, and I'll definitely answer them. So in the next video, let's add Google as our second optional way for the end user to log in apart from GitHub. So thank you for watching, and I'll see you in the next video.
In the previous video, we talked about how we can create a logout functionality into our web application, where once we log into our application using GitHub, then we have a way to log out of it. And while we were implementing that, we saw how we can do that using simple jQuery on the client side, where we have an AJAX setup to make sure that whenever we have some particular types of requests, then we all have the XSRF token ready for security. We made sure that whenever we have a logout functionality, we make sure that it provides the correct buttons as required. And we also made sure that the logout functionality was handled by Spring, and made sure that the logout successful was permitted by web security configure adapter. So we had a pretty simple basic OAuth 2 app ready, where we could log in using GitHub, get the data back. So we got the data back using principal or get attribute using OAuth 2 user, and we printed out the name of the user using that. And in the next set of videos now, in this video, the next video, we will talk about adding a new application to our OAuth 2 application, a new way to actually get authorization. And in this video, we'll be using Google to do that. So Google is pretty much used everywhere for OAuth 2, and Google is a very important company where people definitely will have a Gmail account most of the times, and they will definitely prefer using Google for the OAuth 2 authorization. So it's much easier, much straightforward to use Google than GitHub for people who don't know what GitHub is and who just have a simple Google account. In this video, we'll see how we can actually implement or add Google OAuth 2 within our application with very simple changes. So all we do is add one line of code in our index.html. So we add one line of code here, and we just update our application with this. So we'll talk about how we can get this. So similar to GitHub, we also need a Google client ID and client secret, and that way we can have a Google setup to make sure that it is helping us with authorization. So only with these two changes, which is having an application.yaml with Google client ID and client secret, and an extra line of code in index.html, we will have our application ready. But before that, let's actually see how we can, what do we have to do from GitHub's point of view, similarly to what we have to do for Google. So let's talk about the initial setup. To use Google's OAuth 2 authentication system for login, we must set up a project in the Google API console to obtain OAuth 2 credentials. Now, Google's OAuth 2 implementation for authentication conforms the OpenID Connect 1.0 specification and is also OpenID certified. Now, what you can do is follow the instructions on OpenID Connect, or we can actually do those instructions right now. And once we complete our OAuth 2 credential instructions, we will have the OAuth client secret and client ID, which will help us with these values here. And as we did for GitHub, we would also need to set up a redirect URI, which we redirect to once we come back from Google's authorization. So we need to set that up in our project as well. So let's see how do we actually do that using the Google's API console. So here I have console.cloud.google. This is where we are going to set up a new project and see how it works. So the link for this will be in the description. Make sure you log in with your Google account, and then we can start with the process. The first thing is to create a new project. So we'll start with a completely new project. And we'll see how this goes from the beginning to the end. So let's have a project name. So this is going to be Spring OAuth 2 Google. And no organization for now. And we do a create. This usually takes a couple of seconds to create, so not an issue. And once it is created, yeah, so select project, this one. Okay, so now we are inside Spring Auth to Google, and this is how our dashboard will look like. Now we need to go to credentials. So let's click on credentials, and then we need to set up our OAuth to consent screen, and also set up our client ID and client secret. So we get this warning that we need to configure the OAuth to consent screen. So let's do that first. So go to configure consent screen. So this is basically the page we come up to when we click on sign in using Google, right? So what do we actually want inside that page, and what should that page look like? For the purpose of this tutorial, we'll be using the external user type, where anybody can test with a Google account, just to be sure. Go to create, and here, as you can see from the right, this is how the consent screen looks, and we just need to have our basics here. So for now, we'll just have the basics, but you can definitely customize this based on your own preferences. For now, the app name will be Spring. Let's just see the app name here. So we have OAuth Spring Boot Tut. So OAuth Spring Boot Tut. Support email is going to be my email. We don't need an app logo for now. No need to have a domain for now. Yeah, so all we need to do is have an authorized URI. So we'll come to that in the next sections. So add domain, application domain, and developer email address, and the email address will be ranak1@gmail.com. For the authorized domain, we need to get it from the page, so we'll have the link in the description as well. So we can just close this for now, do a save and continue, and see the redirect URI specifications here. So no scopes needed, no test users needed, and looks almost good. Let's just hit edit once, and no redirect URI here, so good to go. Save and continue, save and continue, save and continue, summary, back to dashboard. So now we have configured our consent screen, and the next thing we need to do is generate the client ID and client secret. So let's do that now. So for that, we can go to credentials, and now we have to create credentials. So we need an OAuth client ID. So let's click on that. Here we have our web application for now, and here let's give it a name as Spring Boot Auth. And here we need to add our authorized redirect URI. So here we paste this, which is basically our localhost login OAuth to /Google. For GitHub, we had /GitHub, and for this we have /Google. This is going to be the redirect URI for our application, and we press on create. Now, when we do this, it generates our client ID and client secret. And as you can see here, we have our client ID and our client secret. Make sure to copy this or download it because it goes away, and it's then you have to regenerate it. So always have this created. Make sure you copy them, click on OK, and that is it. So now we have used the Google Cloud Platform to have our OAuth application set up using Google Cloud, and we have created a new project called as Spring OAuth to Google. We created our OAuth consent screen. We'll see that in a minute in the demo. And we also created our credentials, which displayed our client ID and client secret. Now comes the next part, which is adding the client registration. So now we need to configure the client to point to Google. Because Spring Security is built in with multiple clients in mind, you can add your Google credentials alongside with the ones we had created for GitHub. So as I said, similar to GitHub, Spring Security gives us the registration for Google as well in the same way, with a client ID and a client secret. Now, as you can see, Google is another provider that Spring Security ships out of the box support for. And the last thing which we need to do is add the login link. Now in the client, the change is very trivial. You can just add another link, and this is basically how it's going to look like. So here in index.html, we have our head, we have the login, and here from line 16 to 18, we have our div, which helps us log in from GitHub, using GitHub. And all we have to do now is just do a enter, paste, and this basically helps us to go to Google as well. So we just have an href to Google's authorization, or to authorization/Google, and when we click on this in the HTML page, we will be sent to the Google's consent screen, and from there we come back to our application and it displays our name. So as you can see, there is literally no extra changes to be done for this particular implementation of adding another OAuth 2 service. We had added GitHub in our previous videos, and in this video we added Google to it. And the only other change is to configure your application.yaml to have Google as the client ID and client secret. So now that we're done with this, now that we have our index.html ready, let's run this and see this in action. So hit run. So we have our application up and running. It'll just take some time and then we can start doing it. Now, while this is happening, usually when people use an OAuth 2 feature, what they do is, okay, so the port was already in use. Let me check what's the issue. Yeah, I had a different web server on that particular port. So let me just make sure that the port is closed, and then we can get back to our application. So let's run it again. I have closed that port now. So as I was saying, whenever people have an application where they are using OAuth 2, they make sure that they save or they hold data about their users locally, even if the authentication is delegated to an external provider. So there are two ways to do this. First would be to choose a backend for your database and set up some repositories using Spring Data for a custom user object that suits your needs and can be populated fully or partially from the external authorization such as GitHub or Google. The other thing you can do is implement and expose OAuth 2 user service, or to call an authorization server as well as your database. Your implementation can delegate to the default implementation, which will do the heavy lifting of calling the authorization server. Your implementation should return something that extends your custom user object and implements OAuth 2 user. So all of this information about adding a local user database can be found in the description below in the Spring's official documentation. And that way you can also add a simple database to track your users who are authenticating using an OAuth 2 service as well, rather than just logging in using a sign up or a login page on your own application. Okay, so now that we have our OAuth 2 runner ready on port 8080, let's see this in action. So let's go to port 8080, not 8-8-, we go to 8080. And here we have our login and GitHub and Google. The website definitely needs a lot of CSS and to make sure it looks good, but for now let's click here. When we do that, we have gone to the sign in page. So sign in using your own account. So I can do it via my account, and once we do that, we are coming back here with here, and we're logged in as Ronak Vyas. So this needs to come inside an if else condition, but that's fine. We are logged in as Ronak Vyas and we got the information back from Google. So we didn't change anything. If you see in the /user endpoint, right, it still accepts a principal OAuth 2 user object, which still again gets the attribute name from the HTML. So if you go to index.html, here we have a ID user, and what we do with the user is that we do a get from /user, which gives us the OAuth 2 principal, and we get a name from it, and we then hide the authentication and show this. So this is how we have added Google inside our list of OAuth 2 services. And similar way, you can add other services as well. You can add Twitter, you can add Discord, etc., etc. And this is how we have an extra OAuth or multiple OAuth 2 services running on a single application. So in the next video, we'll talk about adding an error page for unauthenticated users and see how that works. So thank you for watching. I'll see you in the next video. So in the previous video, we had implemented and set up Google so that we can log in or authorize Google for our application. We got into the Google console, we set up a new project, we had used that to create an OAuth consent screen, and we also got the client ID and the client secret from that particular Google console. And then the next thing which we did was have added Google here, which basically just is an href to Google's authorization, and we had the OAuth redirect URI also added to the Google console, and in that way we were able to add Google into our list of OAuth services very quickly. Now in this video, in the end of our Spring Boot OAuth 2 tutorial playlist, we will be adding an error page for unauthenticated users, and we'll also add a very interesting functionality on top of it. So here's what we're going to do. So we have GitHub, which is our initial primary way of authorizing our application. And now what we do is we make sure that only the GitHub users which are part of a particular organization and GitHub, only they are able to authorize into our application. So now we have an extra requirement from our GitHub OAuth users. So they have to have a GitHub account, and they also have to be part of a GitHub organization to authorize or log into our own personal application. And if they are not included inside that particular organization, then we throw an error message, and that's what we are going to implement today. So we'll be implementing an error message for people who are not a part of a GitHub organization. So let's see how that works. So on the client, we should provide some feedback for a user that could not authenticate, and to facilitate this, we can add a div which will eventually add an informative message too. So first, let's add the div to our static index.html. So here we can just add a div, which is a container text danger error. So it gives out a red text message which helps us show that it's an error. Then we can add a call to the /error endpoint, which we haven't implemented, which we'll implement in a few seconds, and populate that with a div with the result. So similarly, what we have done with /user, we do the same with /error. So let's see how we can implement that. Pretty straightforward, nothing complicated here. So all we have to do is %.get /error, comma, function data, and here we do if data $error.html, we fill it up with data, and that's it. Else, if we actually do login, then we don't need anything there. So all we do is have an empty string. So we can just copy this, and instead of data, we just have an empty string here. So in this way, whenever we get an error message from the /error get endpoint, we fill it with the error message, and if not, then we just put it as an empty string. Now let's go and implement the backend for it. So to add an error message, the first thing that we need to do is we need to capture it when the authentication fails. And to achieve this, we can configure an authentication failure handler inside our configure method. So let's see how we can do that. So all we have to do is have an OAuth to login. So here inside OAuth to login, we implement a bunch of stuff. So we do and here we can do a dot failure handler, and inside the handler we have a bunch of information. So inside the failure handler we can do request response and exception. So let's directly add this because it's just boilerplate code. So we have it inside the Spring documentation, and all we have to do is this. And we're good to go. So we have an handler error here. So let's see what's causing that. So the next thing which we need to do is make sure that our configure method is implemented correctly, and we'll be good to go. So yeah, here we have our /error. We have our simple URL authentication failure handler, which is the default /URL, and here we add an OAuth to login, a failure handler, which basically sets an attribute in that particular session. So we save an error message, we set the attribute error.message whenever the authentication fails, and then to retrieve this error.message, all we have to do is add another endpoint on top of this. So here, just like we have /user, all we have to do is add another endpoint, which is /error. So let's implement that now. So let's do a get mapping /error and public string error http servlet request, and we take in a request, and all we have to do is string message equal to, let's typecast it into a string first, and this will be request dot get session dot get attribute, and the attribute is error dot message. So this is the message that we want, and once we get the message from the session, all we should do is delete that attribute, so that in the next session we get a different error message and we don't show the same error message there every single time. So we can do a request dot get attribute dot remove, get session dot remove attribute, and we just remove error dot message since we are already saving it inside message, right? So all you have to do is return message, and that's it. So what did we do here? So here we catch our exception error inside using a simple URL authentication failure handler, and once we are able to handle that, we add it inside error.message. Now when we go to /error, we take that request, go to the session, and get the attribute error.message, which was set when the failure happens. So we set that, we get it here, and we return that back. So this is how we have a /error endpoint. Now, a 401 response will already be coming from Spring Security if the user cannot or does not want to log in with GitHub. So the app is already working if you fail to authenticate, by rejecting a token grant. But to make this better, to end on a very good note, we will extend the authentication rule to reject users that are not in the right organization. And for that, we can use the GitHub API to find out more about the user. So you'll just need to plug that into the right part of the authentication process. So fortunately, for such a simple use case, Spring Boot has provided an easy extension point. If you declare a bean of type OAuth to user service, it will be used to identify the user principal or the main user, and we can use that hook to assert the user is in the correct organization and throw an exception if it's not. It sounds a bit complicated, but let's see how this works out. So let's implement that. So what we need is a bean, and this is going to and let's import the class bean, and next we are going to implement a method which is going to be OAuth to user service, and this will have an OAuth, not a queue, we have an OAuth to user request, and it will also include an OAuth to user.
and this is going to be OAuth to user service, and this will have a web client which will make the request to GitHub to get back the organizations list. So we'll add web client later. So before that, let's just make this method. Now we need to add web client first. So we don't have that yet. So first let's do that, and let's get the web client beam from Spring documentation. It will be in the description below. So a lot of things are required here. So let's import them very quickly. So import class, import class, import class. And we have it right here. So just to have it clearly here, we can do this. And on top we need to import web client, so let's do that now. So let me just find out where web client is, and then we can add it inside our application. So yeah, right here, and we go here, and all we have to do is add the reactive function. So for this we will need a dependency, so let's add that dependency as well. So for that we can go to the pom.xml for this particular file. So let's go to the pom first, and then we will see why we don't have reactive inside our application. So let's go inside the pom, and here we have Spring Boot Starter OAuth to client, we have Xplux. Yeah, we needed reactive Netty. So let's refresh Maven to get that. And cannot reconnect. Let's do that again. We are syncing, and we should be having the reactor Netty in no time. Then we can have the web client ready. So the web client will contact GitHub, get back the principal user, get the organization URLs, and then we check whether we are a part of that organization. If not, we return back an error which we will see in some time. So let's implement that now. So now this should be available, and yes, we have the web client, and all we have to do right now is implement our service. So let's do that here. First, let's have a way of getting back a user from the OAuth 2 service. For that, we'll be using the default OAuth 2 service. So default OAuth 2 user service, which will be our delegate, and this is going to be new default OAuth 2 service. Next, what we do is a big return. So return request, and here inside this, what we do is first OAuth to user equal to delegate dot load user. So in this way we load the user first. Next, we check whether we are loading it from GitHub or not. So if not GitHub dot equals, and we get the request dot get client registration dot get registration ID, which will be GitHub or Google based on what we provide. And if it's not GitHub, then we just return the user that we have, and we are good to go. Now comes the next part. So here what we do is we first go to the authorized client. So OAuth to authorized client, client equal to new OAuth to authorized client, and inside this we have we use the constructor to do get client registration and also user dot get name. And once this is done, the next part would be this. So let's just take a minute to implement this correctly. This is just boilerplate from the documentation, so I just have to make sure that this is correct and nothing is wrong here. So yep, we have the get name and the access token, the client. Yep, the next part. So now we have the client to contact GitHub. We have the user, which will have the attributes of the organization URLs. So what we do is we take the URL from the user, so user.get attribute, and this will look like organization underscore URL, and this will have a Z and not an S, so we need to make sure about that. Now once we get the organization URLs, it's pretty much simple basic math, so let's actually see that in action. So all you have to do is loop through them using REST get API. So let's just quickly do that here. So yep, import the classes that we need. We need it from Java util. We have authorized client, and we're almost done with our. So let's import all of this. Import class, and all we have to do is import our main class. So let's do that right now. So here we can just do this entirely all the way down, and to make sure that it's correct. And get rid of package example because we already had that. Get this down a notch, and this will be OAuth runner. And yep, so what did we do here? This is where we were. So once we get the organization URLs back from the user, we have the URL which we use and contact GitHub. So we do a get URL, we take the attributes as our client, we retrieve or get back the organization list, we convert them to a list, and then we block them so that we can use them in orgs. Then what we do is we check any matches in orgs which are a part of the Spring projects organization. So since I am not a part of the Spring engineering team, I will not be able to access Spring projects. That's exactly what we want, because we want to check the authorization here. So 1 second, OAuth runner. And since I am not a part of the organization, I'll get an authentication error which will say not in the Spring team. So this is the final part of the puzzle. So let's go back and see what we have done. So in index.html, we have added an error div which is populated using the /error endpoint. Next, what we did was we let the configuration know that if there is a failure handler, then set an attribute to the session called as error.message. Then we go to the /error endpoint and we get that attribute back, and we return that back to our application inside index.html. And while this is happening, we also make sure that once a user tries to log in, he is checked to be a part of Spring projects or not. And if he's not, then we throw an exception called as not in Spring team. And that's how we check whether a person is inside an organization or not. So in this way, we see how we can extend the features and capabilities of OAuth 2 services and Spring application to make sure that we have customized rules for our OAuth 2 services. Now for the last part, let's run this application and see this in action. So we will be using a private window and not the usual window, sorry, because I'm already logged into GitHub, but I want to log in again and show it how it would be if you have been using it for the first time. So let's wait for Spring to start, and once this is done, then we can go ahead and test it out. So let's go ahead and open a private window, go to port 8080. So let's log in via GitHub. So let's 143 and sign in. And since I am not a part of Spring projects, I will be giving back an error here. So let's see if I get the error or not. So I've been redirected back to the authorized application. And when I come back, as you can see, I have not been logged in yet. So here we need to check what was happening with index.html. So we go inside index.html and we check why did the error not show up. Container error. Let's check it again. So we have our error.data.html. Okay, so yeah, we made the dot error here, and we just need to make sure that we don't make that error again. So let's run it again since the HTML has been changed. So we have our danger, we have OAuth runner ready, and we have everything else ready. So all we have to do right now is run it again. Should be up fairly quickly. And yep, now we can refresh this again. We are here, we click here. And since I am not a part of the Spring team, I get back not in Spring team. This is how we add a custom error message inside our Spring Boot application using OAuth 2 services. So the entire documentation and the code for this can be found on the Spring website, which is what I've taken as an inspiration to explain this in a video format. And please check that out in the description below. And thank you for watching, and I'll see you in the next one.